It's 9 o'clock. Folks are filtering in with their breakfast. I hope everybody got a good night's sleep. Liam's messing around with the mic. I'm gonna share my screen.
Do remote, just do a quick mic check for us.
I can hear you guys.
Remote, just do a quick mic check for us. Need to mute your local audio or change your output here.
Yeah, 1 second.
Can you guys hear me okay? I can hear
Output
you.
is. We can hear you pretty good. Although I think I might be on a delay.
Your YouTube,
Could be my YouTube.
yeah, your system output is still set to use your local speakers. No?
Anchor. I don't think so.
Command, click on the speaker in the top right on your Mac.
It's true.
We figure it out.
So you don't know how to.
I don't think so. Okay. I'm gonna share the board link again to the chat. Yeah. Hey, Andrew, do you mind talking to me like we're having a conversation just to make sure I don't have some significant delay?
Okay. I can hear you
Oh.
okay.
I can hear you really good too. Okay. All right, we did it. I don't know what I changed, but seems good.
Cool.
All right. Up in like 10 minutes? Something? Yeah.
Oh, really? We're starting? Okay.
Yeah.
Some more time.
Okay. Okay. And so, but what we're gonna first do is come up with what we want our breakouts to be. Right now, what I have pulled up on the screen are stickies for what our goals are, for the summit. Maybe some of our big concerns. I just heard another concern of something that we should discuss, while we're here. And inside the agenda, I also dropped in a bunch of different things that are sessions that I know folks are interested in, but maybe are a little bit shorter, so we didn't need to dedicate 30 minutes to an hour on. The idea of this is that it's going to be a little bit like an unconference. So I'm going to grab one more of these. And I'm going to create a new area over here, and I'm going to call it breakouts. And I'm gonna drop a bunch of stickies in. What's a new color today? Today's blue. And I'll make, I don't know, put a bunch in here. If there's a session that you especially are interested in joining, or discussing, and estimate how much time you would like to dedicate to it. This is sort of the idea of an unconference, is that maybe we learned new things yesterday, maybe there's certain stuff that came up, or you know, it's something that you know that we've needed to talk about for a while, and now you've got the opportunity to do it. Right now, I'm thinking the way that this will work is that we'll have two different sections. We'll have one group that's running a breakout here, and then we'll do a simultaneous group that's doing a breakout on the other side of the room. And that way we will be able to cover a lot more content, and you get to choose which discussion is most interesting to you. So I'm going to start creating a couple of these stickies, but I also welcome other people to jump in. For example, I asked Nick if he would run a debug session. So I think this would be a really good one to have. And yeah, Lan, come on in. And on that, we'll go into a little bit more around planning right now. So as people in theory are waking up, they can also add into the breakout. So you'll have at least 30 minutes, I think, to come in here and add to it. I'm also gonna let the voting period be let's say 10 minutes on this. And I'll give everybody, depending on how many stickies we get, 2 or 3 votes. And so I will take the ones that have the most votes. I'm gonna put it right here at this table so that it's easier for folks online. And then the ones with least votes will be on the other side. So online people will have one track. Good morning, Yash. So Pat and I were interested in exactly what Joel just responded with, which is how do we define what is and isn't WASI? What are good things to include in WASI? Maybe what are some things that we should talk about excluding? And yeah, so that was something that Pat and I definitely wanted to chat about. And you know, if I think we can jump through each one of these sessions. If there's ones that people don't know, and if you added the sticky, I'll ask you to tell me about it. But I'm gonna let us build stickies for maybe 5 more minutes. Totally. Hi to Bagel. You guys see that pretty good? And ideally, each one of these sessions is like maybe 15 minutes or less.
like. Let's configure serializable. That's probably should be a breakout session. This seems a little.
I mean,
Seems a little, well, I guess they're 15 minutes. They're not that big, right?
yeah.
All right, so. I'll add it. Still add the structure. We have like a single list.
Folks that I see just joined, we're adding breakouts. So add topics for discussion. Anything that you're interested in doing, maybe a little bit more of a dive into. Maybe something that you want to reach consensus on or a cool idea you want to present to the group. Everything is wide open for what you want to add here. I'm gonna give it one more minute to add stickies to the board. And then. Right now we have 12 topics, so I'm gonna divide that up with 3 votes.
Yeah, see my question.
Nope. And yeah, the idea of an unconference is it's for the people, by the people. I am not gonna be talking. It's probably a relief to most people at this point. Certainly for me. Getting some more. 1, 2, 3.
SSA. Reminded, I guess.
I approve.
No, we're just talking about like what's the process for O21 and O2X. Write up a document of like what I think just like about you with that.
Present it to the SG.
Send this to you,
Yeah.
and then we'll vote order and say like, this is our process, just like we did for two itself, it's like we had the process, we voted on the process, and we did the process.
Yeah, but I like the sound of it. Nice clarification. About the right time.
I don't think I'm gonna be too picky about it, but whatever helps us move quickly.
Even if it's like, oh, we're gonna get this is time.
But I don't.
Actually, do this right now, you just,
Maybe we'll get some stuff.
I have
You answer the questions that right with market, we have those like impressively, so it's. Seems like just the right time. Right, I'm supposed to say, all right, so we're gonna start obviously doing something post no 2 hours. How are we gonna do that? Like, what are we gonna update, what, when, where, how?
It's really satisfying. Actually.
Yeah, I guess being able to use it post.
We now copy material, and we've been trying to set out the same kind of thing in the time. Right, you didn't bust it.
Yeah.
And then the starting to avoid being like, I actually avoid. So, and that's the question.
Oh.
Thank you, Liam. Oh, yeah. Get 3 votes.
well, we don't validate it.
And I'm gonna give it 5.
Yeah, that's kind of what.
I don't use that.
It's kind of like, we'll make it modular, like, we have no idea how to make it modular.
Oh, I remember.
Is anybody else creating sticky?
They were assumed that it was, yeah, it's very good point.
Alrighty, folks, I would like I'm gonna start voting. Pick your top 3 discussion topics that you're interested in going to. And or helping lead.
Other.
Okay, so.
They're all like totally.
Yeah, so. It's like, the stuff that. I share, and I'm happy to know that we're.
Yeah, this 2 million is, yeah.
I think I've been a certain foundation of it. So they use it. That's right. Every guy with an SQL. Okay, very narrow. That role is. So that's. Whatever. You should like involved with stuff that's. I think I have to call with it, hey, we yeah, that's the right. But I did the hard really needing to
Like this question.
I moved everybody to schedule, which it made all this public because that we wanted, so I did all the different, the hard admin part of like. Our tool. So like building.
But the thing about like, we, first off, like, just like your. I do this like MDU. But they have like,
I'm sure it was. Yeah. Okay, that's what that's when, yeah.
It's Java module source. Modularized the runtime to chop it up. Unlike we have, but they did it after the fact for the same reasons, which is they went, not every place you had a JVM wanted all of it, so they needed a hard way to modularize it. So Java modules, Europe. It's not quite adopted in everything, but as they speak, so runtime modularization feature has been. So we have one and Q and then Java 21. Well, I guess that is sort of like our process, right? It's just look at them, see what they do. It's very easy to think about this because somebody was like, but I'll try my job as much. Slash as well as slash, but I think their modules are source correct. Yeah. I don't think that's like.
About 30 seconds left. Get your votes in.
It's.
That's. Good job. I guess because that means the how it's just. But they also publish information about standards and scripts. It's like documentation. I think it's like what you should say, there's like other documentations that it's like, but not much, use just the one thing, right? So like, here's the one, but that's that. It's stuff to say, but I'll just all that it's or yeah.
Hey, Luke. Are you ready?
Yeah, did you see? I sent you the link to the version.
I didn't.
I told Joel that it's gonna do the last 10 minutes. So I was wondering if you could help remind me when we have 10 minutes left so I can,
Okay,
or
easy.
maybe 15 minutes left so that way I can know to have 5 minutes to wrap it up and hand over.
I gave it a block of an hour, but we can do it faster or slower, whatever you prefer. You know, today's pretty flexible. While you're presenting.
Oh.
Thank you, Ralph. You're still my favorite. I'm gonna be organizing the Miro and stuff.
Oh, so I should have my own laptop.
Nah, don't worry about it. I'll give you my laptop and I'll steal another laptop.
Oh,
We have a couple.
Yeah.
So, folks online, I believe we're just about out of time for voting, but either way, it doesn't matter. I'm stop sharing and I'm gonna move on to planned programming while I try to figure out how to organize the rest of this thing. I've got it pulled up somewhere. Did it. Woo, we did it. Yes. Two different Zoom meetings.
So why don't you want to leave people in the main room for one, and then we'll create a second one?
Sounds great.
Second.
Okay, cool. Sorry. Multitasking.
I'm not sure why.
Consistency is hard, hey, you know, that's a good lead in.
And also,
I'm gonna just like slink away if that's okay, Luke.
it's good.
Luke, if you have a good Zoom on your Fastly computer,
I do.
want to drop it to second Zoom, or want to be the host for the second meeting, or which session are you gonna be?
Well, this current async one, which is like before the breakouts.
Yeah, they're just gonna be the second chair. Bailey, who's gonna be your second chair?
My second chair would be Karen.
Okay.
Until this Karen comes in.
That's the source code. Like, no, I'll ask. Right, so here's the thing that I actually do. Source code, like let's just like.
Otherwise,
I have like takes in context of the source and it emits tokens that use that same like.
I've got one, I've got one, I can give that to Karen, but
Are expecting that the source like that. Go through here, yeah.
so, but I can decide.
It becomes an increment. And then we parse that. And parse also knows.
I don't see Karen on Zoom yet.
And produces.
Yeah, but it could be a little. We got, okay,
It's not starting right now.
okay, super, never mind, great.
I asked Luke to help us talk about preview 3 planning, especially around async and what that means. And I think everybody was really interested and excited about it. And so I give you Luke Wagner.
Hey, everybody. So, yeah, well, I guess these are, this is an update on the async sketch. If anyone was remembering, maybe more than a year ago, I did like a rather long sequence of presentations. And this is all before resource types on how async might work. This is like a much shorter and condensed and also simplified update of that sketch, just based on, understanding of the last, of the last year of like doing resource types and ownership and all that stuff. So this is a hopefully much simpler proposal that still achieves those goals. So I'll start with just trying to what is the problem we want to solve, and I think WASHP gives us like a perfect concrete example to like identify the problem and say what we want to fix. Then I'll describe kind of like abstractly what the goal state is, and then give a high level design summary. Then talk about kind of how we can break this out into some milestones. Then dive into a few more like medium level design points. And then finally, Joel just recently got a really cool experimental sort of prototype working that you can think of as like the first step towards like, part of what this is proposing. Like we'll be able to characterize it more precisely later on. But so we'll end up with actually being able to see some kind of working code. So awesome job, Joel. So starting off, let's say, before in the very beginning, and several people's sketches and prototypes they made, WASHP could have been so pretty. It could have looked kind of like this. There would be a request resource, and you just construct it, given a nice little list of bytes out of the body. And of course, this is overly simplistic. You'd have a separate resource for a body, but just so it fits on briefly on a slide, you just pass in a list of U8s as the body, and when you consume, you get a list of U8s as the body. And so, same for response. And then the handle function at the bottom, this takes a request and returns a response. It would be so nice. And it's modular. It's not coupled to any other interface. It's just its own little freestanding thing. It's not dependent on some monolith core that has to be like kind of like special or magic. It's just its own little HP thing. It's also very composable. So Peter's going to be talking about this later today, but WASM Compose has this upcoming kind of composition language that I'm just showing a little snippet of, just because it's such a nice concise syntax for like describing composition. So let's say I have two microservices, quote unquote, but they're just components that are targeting WASHP. I make the first one, I give it a key value store. I guess technically not targeting literally WASHP, but it's importing a KV store and exporting a WASHP handler. And the next one imports an HP handler and exports HP handler. So I can just compose them together, just like that. Just link them together. That looks really nice. Kind of this is like a visual representation of what I'm linking together. And this is kind of a little bit. You can think of it as like a non-distributed version of a service mesh, where I'm just taking two microservices and linked them together. It's also, you can think of it as a little like a Unix pipeline and how I'm going to snap them together in composability. But it's fundamentally more expressive than Unix pipeline. We have it's bidirectional. Unix pipelines data flows in one direction from standard in to standard out. Down the line. Well, this gets to go that down and then back up again because we have call return. And also, any microservice can call each other 0 to n times, not just once. So it's kind of like, and so you could say like this difference in shift and expressivity is from first order composition of pipelines to higher order composition. And that you could say this is why people do tons of microservices in practice, but not every program is implemented as like Unix pipeline. It's because you actually want this expressivity. And this is what we would have if only WASHP could look that simple. You can do these nice, there's like a show of the control flow, calling into one, and you can hop in the other microservice and go back, and hop in again, and return back. So this is a thing that we would be able to do if only WASHP looked like that. But then, concurrency. What do we want? What are our requirements here? Well, we got to have streaming bodies. Why? Because they can be really big. We don't want to. Also, we want to care about latency. We want the first byte. I want to see it before the last byte arrives. And some things, use cases like long polling, like critically depend on this. Next, we want to have multiple outgoing concurrent requests. So I can send multiple HP requests in parallel. And nice to have, because actually various places don't have this at all, is concurrent incoming requests. I want to be able to have multiple requests handled by the same instance, interleaved executing, so we can increase the density of reuse. And naive HP can't do any of this. It's that source of beauty was also its undoing. That's why we can't have nice things. And I think this is true for pretty much any WASI API. There's nothing actually HP specific about this. If you've got a large list of bytes, you're going to want to stream it. If you import IO operations, you're going to want to be able to issue multiple in parallel or currently. And if you have incoming IO, like triggers, like the HP handler, when you get given a request, you're going to want to be able to have multiple of those executing concurrently. And and if you give a nice composable looking sync function call interface, you won't be concurrent. And so you're going to have to do what we did. So what were we forced to do to be concurrent in preview 2? First of all, we had to split request into two for incoming and outgoing, and then response into two for incoming and outgoing, returning an input stream and output stream. And then we have this, special magical WASI-IO, which defines a resource type pollable. And we have a poll function that, given a list of pollables, says, which one's ready. And then all these different, places of, input streams and output streams transitively will give you one of these pollables. And so you can have lots of different operations in flight that give you pollables. Then once you have lots of things in flight, you can poll, say which one's ready to make progress. And so I won't go into the precise details, but I'm kind of just giving a sketch of, what we did instead. And so, there's a loss of modularity here. Poll has to know about everything. This one function poll has to know all the different kinds of async stuff. It has to know about HTTP. But if we also have, IO, file IO, it has to know about that. If we have sockets, it has to know about that. It's this one pinch point function. So, WASI-IO ends up being this kind of like magical monolithic thing. And anyone who's tried to virtualize WASI-IO kind of knows this. It kind of just problem forces itself upon you, and you're like, this doesn't feel like that modular, dream I was pitched. You're like, yeah, concurrency, man. So, and what happens, that handler interface gets split into two. There has to be a different one for incoming that has the signature where you get given a request and an outgoing response, just a simplification of what it really is, and then outgoing where you pass out an outgoing request and you get back as a result an incoming request. Importantly, and this request handling isn't even concurrent in this model. And importantly, they're not the same interface. These are different types, like fundamentally, and you can't just trivially it's not like in some superficial way. So what does this do to our composability? Well, that nice little composition I showed just doesn't work. Why? Because when I try to link them together, microservice 1 exports an incoming handler, microservice 2 imports an outgoing handler, and they're just not the same or trivially adaptable. And so how do you have to compose instead? Well, you have to run each component in a separate thread using post magic powers, because that's just not a thing you can do right now in the component model. And why? Because once a single component calls pull and blocks, well, if they're all sharing a single thread, well, then they're all blocked because there's only one thread and you just blocked it. So if you want them to actually run concurrently, put them in each thread using magic coach powers, and you're like, oh, I had to step outside the component model to compose. So we've lost compositionality. Yeah, and it's not ideal to require threads because we want to certainly allow you to use them, with components, but we don't want to say they're the basis of how we compose when currency is involved. We want to allow but not require threads. So ideally, my ideal world, and actually spoiler alert, I think this is what in preview 3 we'll be able to write, is I just want to take that original interface and just cross out the list and write stream instead. And that's it. That's the WASI I want to write. Now, obviously, real WASI is a little more complicated. There's bodies and there's fields and all these things, but basically that's the fundamental change I want to make. And there's no WASI-IO in this picture. There's no monolithic core where everything funnels through, and it goes back to being composable. Now we have the same handler interface, so my two microservice components can just compose. So that's the way I want to write. That's the way I want to standardize and publish. So how does that actually give me the concurrency that are the requirements? So here's the TLDR, and this is just a very brief high-level summary, and then I'll kind of recurse into each of these. So first, we need to, I think, what we're proposing is to add a new async canon opt to canon lift and lower. So canon lift or lower are basically how you go between a component level type and something core WASM can import or export. And we have all these canonical options, like string encoding, where you get to say, how do I want my string to be written into linear memory or one day GC memory, as we were talking about yesterday? Well, to that same place of how do I want it to look precisely, we can add an async option. And async, and I'm going to hand wave here and just say means reentrancy, which means being able to run new invocations while something's already running. And I'll say more in detail how this actually works. And so as a canon opt, like string encoding, async is not part of the type. It can be uniformly applied to any function type, just like, all the other canon ops. And it can be independently chosen by the caller and callee, because it's, on one side or the other or both of a particular, function call. And it can be independently chosen for each import and export, which is actually going to be useful, as we'll see. And that's exactly kind of what we need to handle all the use cases that we have. Separately and orthogonally from that, then propose to add a future and stream type that can be used in parameters and results of functions. This is what I showed on the previous slide. I consume can return a stream of U8. They allow incremental delivery of values as opposed to passing or receiving parameters and results all at once, which is how they work today. All the parameters get given to you and then you run, then you produce all the results and they get copied and the caller gets all the results at once and then they run. So this future and stream, they're about incremental delivery of parameters and results. And so with the design, we make async totally orthogonal from the use of the future and stream type. Where async gives you reentrancy, where future and stream give you incrementalism. And that means you can, for example, synchronously lift a function because you're non-reentrant code, because let's say you're C or Python and you're just not, the code this is fundamentally not reentrant, you don't expect to be reentered, but you can still use streams because you want to use streams because you want to not So, and this is what you need for all the languages that aren't inherently async, like, so REST async, JavaScript promises, C# async, these languages, are fine with being reentered. But a lot of other languages, just you can't force this on them. So we want to be able to have these orthogonal concepts. So that's a high-level sketch. Expect there's still questions, so let me go into a little more detail. And then after this detail, I'll show some actual diagrams with call stacks, and we'll see kind of how it works in practice. So let's see how lowering async works. So already we have this concept of canon definitions, which lets you lower a function. So ignoring the async part, this would say, given a component level function f, can you see my, yeah, you can see. Use this memory to, read and write its parameters and results. Use this realloc function if you need to dynamically allocate memory, and give me a new core function f that can be imported by core WASM. So this is already a thing you can write. And the new thing is, additionally, in addition to these other options, I can say async. And when I do that, this core function will be given the fixed type that doesn't even care about the type of f. I give it a pointer to a tuple of parameters and a pointer to a result tuple that will be written into, and I get back a state of the call and an index into an internal table that holds an index to the asynchronous call that may be in progress. So digging into that, the param tuple pointer, result tuple pointer will point to, well, a serialized tuple of whatever the parameters and results are, which is already what we do when you exceed the maximum number of parameters or results that will flatten. And when you have too many of them, we already stick them in memory. Well, we use the same thing here. We're just always putting them in memory, basically, instead of trying to splat them out into different I32s in the results. So that's not a new thing. We're just going to do it always because it's what we want. So once I make this call, it'll return to me without blocking, and it'll tell me what state the call is in. So there's 4 states. The first one is the call hasn't even started yet. Why? And I'll tell why this case is very useful next, but the call hasn't started yet. So therefore, I haven't even read from that parameter tuple. Keep it live. Don't free that memory yet. Keep those parameters available for me. And then wait on this call index to know when they have been, when the call has actually started. 2, the parameters have been lifted, so you can free that tuple, but keep waiting for the results. They're not ready yet. Keep that memory live. We're going to write into it a little later. State 2, the parameters have been lifted. The results have been written into the tuple, so you can use them now, but the call's not done yet. It's still finishing up. It maybe is going to do some billing or some logging or some final stuff. It's not done yet. And 3, the call is totally done. It is released. The memory is freed. The index is gone. And so we're done here. So it's possible for because state is a return value, it's possible that I will make this async call and it will finish. There was, it just finished. There was nothing to block on, so it's already done. So I didn't even do an async call. I didn't allocate a resource. You can return a Rust future that's already ready. So it's possible to go straight to state 3, but it's also possible to go to any of these earlier states. In that case, the call's not done yet. So given this call index, well, how do you wait on it? Well, that gets into lifting. So this is lowering how we call imports. Let's see the other side of this, which is how does our exports get called? That gets into how lifting works. So when we're lifting, we're going the opposite direction. We have a core function exported by core WASM that we want to lift into a component level function that can be called from the outside. We're going to say, use this memory, use this realloc. That's already what you can say. And the new thing is we can say, I want to lift asynchronously, and here's my callback. So this is a second function. So I have 2 functions I'm giving here, the callee and then this extra callback function. I'll explain what it means shortly. So that's what's new. And then the result of this will be a component level function. And let's just say whatever, I give it some type string to string. So when I lift, this core function must have the fixed type. It takes nothing, and it returns whether it's done or whether it wants to keep going. And here's a closure pointer that will be passed to my callback. So returning done equals 0 means wait for something to happen. and then call my callback given this closure pointer, which is like the void pointer sort of low level Unixy kind of callbacky pattern. So that's if I'm not done. If I am done, then the call is done. There's nothing async that needs to happen. I didn't end up blocking. The callee, before returning done, must have, and this is enforced by a trap, have called two built-ins. So while it's running, it needs to call two different things to be done. One, it has to start. And when it starts, it gets its parameters. So when I call start, I pass nothing. And then we use the normal canonical ABI to copy the parameters into my memory. So this lets me wait until I'm ready to receive the parameters. And that's when I call can and start. And if I don't call start and I return, what I'm saying is, hey, I can't even receive this stuff. I'm already backed up. This is back pressure, right? Because the allocation of like a list of U8 pushes memory into my space. If I have a slow other side of a stream, I need to say, hey, don't do it yet. I'm gonna So I need to be able to exert back pressure before the call even starts. This is useful for this reason, but there's even more useful for the next reason I'll get to later. But critical thing not present in the initial sketch is back pressure before a call even starts. So that's task start. Task return is the opposite. It's when I go the opposite direction. I give you a pointer or the canonical ABI representation of my return values, and this copies it into the caller's memory. So I can task return. And because when we have task return, we don't need this post return anymore when I'm doing async stuff, because as soon as task return is done, I'm post return. I have returned my values. I can keep running, and I can keep waiting and doing all the other stuff. So these are the two things I need to do before my call is done. To start it, which gives me the parameters, and I have to return, which lets me pass out the results, all before my async, and I can just keep running after the return to finish up what I want to do. So that's that. So now let's say I do have to wait. I return done equals 0 because I need to wait for something to happen. I need to wait for progress. This callback gets called with the closure I asked, and then an event, which is like a kind of a union discriminants. And then these two I32s, which are just like, you can think of as like, two raw bytes that are interpreted by what the event is. So this is like a flattened union here. And then I get to say after this callback, am I done now or do I keep going, waiting on the callback over and over? So this is kind of our event loop system local to this component. So if I return done, same rules. I must have called start and return, or task start and task return by the time I'm done. And the event says what happens and how to interpret the payloads. And initially I'll add more cases, but the initial one is event 0. I'm just making up the numbers here, but let's say event 0 says I made progress on a call, and payload 1 contains the new call state. I guess payload 2 would be the call index. But what this is saying is, hey, one of these subcalls you've made by calling in imports has made progress. This is the new state the call is in. So if I called an async imports and I was waiting for it to return its results, and the state is now 2, I know, oh, the results are ready for me. I can, proceed on that import. So this is how I wait on all the import calls I've made, is I wait to hear progress on one of those import calls. So that's, a lot of abstract kind of rules. Let me talk through an actual call stack and progress. So let's say we've got these two components linked together, and we're going to do the case where they're both async on both sides. And we're going to actually walk through when one side's async and the other side's async. So we'll start with the both async case. So, the x-axis is over time, and the y-axis is the native call stack, what's actually happening in the VM. So, we call in to c2.handle. This is let's say it's washp, so this is the handle function of washp. And that starts this task, gets its parameters. Then it calls into C1's handle function. It's C1 starts its task, gets its parameters from C2. That transfers ownership of that request handle. And now C2 wants to call the key value store gets, which ultimately, let's say, is implemented in the host. And this is where we would block. We're like, okay, we're going to have to do a network call here. So this is where we would block. If this was a synchronous call, we would just block here and not return. But instead, we will return because C1 lowered with async. It will say, okay, I've created a call at index 0 and it's in state 1. I've read the parameters, but I don't have the results yet. And this will return, and C1 will say, okay, well, I can't make any more progress, so I'm going to return. I'm not done, and I'm going to return a closure pointer, some arbitrary number I picked, pointer to memory. So now 2 gets control flow, C2 gets control flow, and it says, okay, a call was created in C2's tasks index space. It has index 0, and it's in state 1, which is the parameters have been read.
And now C2 gets to like keep running and it says, okay, I can't make any more progress, so I'm not done. And here's my closure pointer. So then time passes. That host.get, that network request finishes. And so the host now calls back and says, okay, C1, we've made progress. Here's your closure pointer back. Call index 0 made progress. Now it's state 3. We've got our results ready. You can now have the results from the gets. You can keep running. So C1 computes its results. It does a task return to pass out its results. And then it returns, okay, I'm done. So it returns to the host. Now the host says, okay, well, I know who was waiting on that. It's C2. So it calls C2's callback and says, all right, here's your closure pointer back. Call index 0 made progress. And now it's at state 3 of your return value. Task C2 returns its task results, which is they handle to a response. And that returns to the host. And now we're done. So that's the whole call sequence. So in general, I've showed just one callback invocation each, but they can be interleaved over multiple things. If we're streaming, we're going to be like, if C1 is, we're streaming from the KV store into C1 and C1's transforming that and passing that into C2, there'll be lots of interleaved callbacks between C1 and C2, just like an event loop, as if they were all part of if they're all written in JavaScript using a shared event loop. Yeah, but they now have different languages and we're interleaving them with an event loop because they're both async and using this callback ABI. So in general, they can be interleaved. And the other important thing is that C2, after it's made this first call into C1, it can call back again, right? C2 can make a new export call into C1 and do another concurrent handle, and it'll just be more callbacks with different closure values that are interleaved. So this is kind of like a very low-level ABI on which you could build, Rust promises, Rust futures and JavaScript promises, etc. So before I move on to the other composition scenarios, I'll now pause here and say, after all this huge dump of Sketch, does anyone have any questions? David.
Does cancellation fit in there somewhere?
Yeah, there's a slide on cancellation. Totally, cancellation has been thought about.
Excellent.
It's a very important aspect, critical part of design. Anybody else? Yeah, Rob.
This is multiple return, which we don't currently, is it broadly supported enough? That's something we can do safely now?
Oh, it can, in the places that we want to use it, because they're not like general purpose, like LVM stuff, it's like magic, Pilar intrinsics, I think we can. If we couldn't, we'll have to gross it up.
Yeah.
So I hope we can. I think so.
Are we going to be able to debug these?
Well, that gets into structured concurrency and having async call stacks. Because yeah, we do want to debug and we want to see async call stacks in our debuggers. So yes, that has been thought about too, but obviously we're going to have to do debugging in general, right? Like we need to be able to debug this. And I think the structured concurrency is the key thing, which I'll get to also later.
We have some chat questions.
Yeah.
From Yash. Does this model distinguish between managed tasks and unmanaged features, async primitives?
What Yash, what do you mean by managed or unmanaged?
Joel says it's that in the slide on structured concurrency may help address this.
Great. Yeah, we'll get to that. There's some rules for how long tasks can live. Yeah, so maybe we'll revisit that question once we get there.
Scott Way has a question. WASM exceptions have any impact here?
WASM exceptions, yeah. So in general, right now, in the component model rules, if an exception bubbles up all the way to a component boundary, it traps. You basically have to catch them yourself and turn them into something, a return value, usually a result value. Results are the thing that are meant to interoperate exceptions with non-exception languages. You catch your exceptions, turn them into the failure case of a result, return that result. The other side sees the results. If it's got exceptions, it rethrows it or does a Rust result. So result types are how we kind of logically communicate exceptions across component boundaries. And so if an exception bubbled up to the root of the call stack of the native stack in any of these cases, it would trap, just like we do today.
And then Dave is asking, are closure IDs protected by the runtime in some way, or can malicious parent components pass any integer?
Great question. They're totally encapsulated by a component. So I'm not showing it here just to simplify the diagram, but like there's like a hard boundary between C1 and C2. Like C2 doesn't get to see that the closure X value of C1. It's an I31 pointer into C1's linear memory. C1 controls that value and controls the allocation of that thing. C2 never gets to see it. It's a little bit like the rep of a resource. Right now, you don't get to see the rep I32 value of a resource type when you're on the other side of the component boundary. It's an encapsulated detail. So similarly, closure is encapsulated. Anybody else? Well, yeah, I'll pause after the next examples too. So that's the, in some sense, easy case when they're both async. Let's talk about the mixed ones because these need to compose. So let's start with the easier of the two cases when sync calls async. So sync means we've lowered synchronously and the callee is lifted asynchronously. So we call into C2 handle. It's a big old synchronous function call. It's going to call into C1. And so I'm going to show that something I left implicit in the previous one, which we always call through an adapter, right? That's the case of today. When you call between two components, you go through this fused adapter, which sees both sides and kind of says, I know what both sides want to do, so I'm going to do that thing efficiently. So it sees I'm async calling, I'm a sync caller calling an async callee. So I'm going to do a thing. So I'm going to call C1's handle function. It's going to start the task. It's going to call the get. It would block. So it returns to C1 just like before, which returns, okay, I'm not done. Here's my closure. But because this adapter knows C2 is a synchronous caller, it's going to say, well, I need to spin the event loop right here. So it's going to wait right here. And eventually we'll finish, which will call back into the callback, said, okay, we made progress. It's done. C1 will return its results, say I'm done. And now the adapter says, okay, well, we're done. The caller can now synchronously return its value. And so C2 returns. So that's kind of what you would hope, nested event loop, basically. And so that case works. That's the easier one. The harder one's next one when we invert this. But I'll pause here. Any questions on this? All right. Moving on.
Sorry, how does
Oh,
the
yeah.
adapter spin the event loop?
Well, I mean, it's up to the host implementation. If you are doing fibering under the hood, like several of us are, it may actually unobservably to the caller swap the whole fiber out and like run other WASM, on this native thread. So what it means to spin the event loop, but it's going to block on, it knows that we're waiting on a host call here. And it's the host, right? So it knows about that. It sees that host gets, and it knows at the, the host is here where we would block, and the host is here where we need to wait for it to finish. So it knows the host can do what it wants here. It can use Rust async stuff. It can use fibers. It can use actual synchronous blocking IO. It can do what the host needs to do. All right. Moving on. Let's talk about the fun case, async calls sync. So we call into C2, it's async. It starts its task. It now calls into C1. And it's, now we have this adapter that knows that the caller is async and the callee is sync. So now we call into C1, which is a synchronous function. It calls the host get, which it expects to execute synchronously. We get to the point where we would block. And at this point in time, we suspend the fiber. So the fundamental functionality here is we're going to suspend this stack and return back to the adapter so that the adapter can return back to C2. Because C2 doesn't want to block. C2 is saying, if you would block, return control flow to me so I can make progress, so I can issue other IO. So the fact that C1 is synchronous shouldn't kind of break the asyncness of C2. If it did, it wouldn't be very, C2 wouldn't be actually being lower, it wouldn't be lowering async. So we need to return control flow back to C2. C1 has, is on the stack. So what do we have to do? We have to have suspend that stack. And this is that same feature of stack switching that we're talking about core WASM, and the same feature that's implemented in JavaScript promise integration in browsers. This is that kind of switch the stack operation. That's like the kind of fundamental low-level primitive that we're kind of adding here. So we suspend this stack so that we can return to this adapter, which now returns control flow normally back to C2. It says, okay, there's a call created, it's not done yet. C2 can keep making progress. So we're going to talk about the harder case next, but let's talk about the easy case here where C2 just says, all right, I'm done. I'm going to return, I'm going to wait, and then time passes, the host call finishes, so we resume the stack now. Now, the host doesn't literally have to suspend itself. It could be doing async stuff, but it's logically, from the perspective of C1, suspending and now resuming when it's done. So it finishes, the host has its result, it returns that result to C1, C1 gets to keep running, and now it says, okay, I'm done, so it returns. And now that C1 is done, the host knows I can resume C2 and say, okay, This call has made progress, the results are ready, and now C2 gets to run and finish and result. So that's the kind of the easy case. The hard case you have to now ask is, what happens if while C1 is suspended, C2 tries to re-enter it? Because it can. C2 doesn't know that C1 is synchronous. From its perspective, it just called a function, as asynchronously, it's suspended, got control, so C1 can call it again. Or so C2 can call C1 again. Furthermore, C1 can be imported by lots of different components, and one of those other components has no idea that C2 called C1 and C1 suspended. C3 now wants to call into C1 because that's what you're normally allowed to do. So we have to handle this case, and we don't want to trap. So what do? So I just shifted the same diagram over. So we get to the point where we called into C1, it suspended its stack, we return to C2, and now C2 wants to call back into C1, let's say. And we call into that same fused adapter. The fused adapter knows both sides and says, I see that C1 is suspended. I can't re-enter it now, it will blow it up. So instead what I'm going to do is exert back pressure. Back pressure was the key ingredient. It's before making a call, there can be back pressure. So what we return is that, there is a call was created, it hasn't even started yet. Your parameters haven't even been read yet, right? So the parameters are still sitting in C2's memory, and the call hasn't started yet, but it does have an index to a call that represents the async call it started. So now C2 says, okay, I can't make progress, I'm going to return. I have 2 outstanding calls now. And so time passes. The original host call finishes. We resume the host call. It returns to C1. C1 is now resumed. It has not been re-entered. It just synchronous call returned. It now says I'm done with the results. And now we have 2 choices. One of the 2 possible things that can happen. One thing that could happen is the host knows, C2 is waiting on a second call to C1. It has that knowledge because this fused adapter here, when it did this suspension, it kind of added a little. It recorded that state. So we said, okay, the first call's done. Now let's make the second call into C1. Let's sequentialize it. It's as if there was a lock here. So now we make a second call, and this one calls in the host, this one blocks, and we turn back. C2 now can receive the notification of the completion of this first task. So this first task finished, returned its results. So we can now deliver the results from this task to C2, even though the second task just got started. And importantly, this delivery of this event to C2 could be swapped around with this starting of the C1 thing. You get better parallelism if you start this one first. So a scheduler would probably want to do it first, but it could technically do either. It's both valid interleavings. Anyway, C2 now gets to run. It gets to receive its results. Time passes. The second host call finishes, so it resumes. It returns to C1. That says it's done now. And now C2 gets a second call back saying the second subtask is finished. It's made progress now, and now it's done. So pause here. Any questions on this one?
In one, it's called a host function, which would block. But what's to say that C1 isn't sitting in some type loop? Could the runtime also be smart about it and say, oh, this thing has been running for a while, maybe I can suspend C1 preemptively and do something there? Because if C1 never calls in to the host and it's just doing something for a very long time, that's also blocking.
Oh, I see. Yeah, that gets into, is it cooperative or preemptive?
Okay.
So I've thought about a canon built-in just called task.yield, where if you're a good citizen in your hot loops, you put a task yield that says, yeah, maybe now. Doing it preemptively adds a ridiculous degree of non-determinism, which is real scary, but task yield might be a good compromise that is for exactly that scenario. And so task yield is like, I'm calling a trivial host call that could block, but so yeah, task yield, and so this would be a canon built-in. You can just import it from core WASM and just call it, and it would just at that moment be as if it was a host call, kind of like what you're saying.
But I guess then that means that synchronous, components that have synchronous functions need to have some sort of knowledge that they might be called in asynchronous contexts.
Well, if you think about single-threaded concurrency, because we're not talking about threads here. The real enemy here is when we block an IO and other progress could have been made. If I'm running compute, it's valuable compute, right? I'm not wasting cycles, I'm not wasting the core. So in some sense, the reason to add that task yield is because you're like, well, it's a long running thing that, but yeah, it might be a thing you want to add if you're implementing a component that has really long running stuff that,
Assuming you're not like spinning against some really quick synchronous thing and being like, oh, it's not ready yet, I'm gonna keep spinning, in which case you are actually blocking on IO, so you look like.
Spin loops are bad ideas.
But as long as the API doesn't actually do the covers, then theoretically your loop is work and not blocking, but yeah, anyway, yeah.
Good question, though. Yeah.
Work focuses on throughput. Sometimes you care about the latency of the response, so then we want that, yeah.
There are two things in chat,
Mhm.
and I also have a question. Josh is asking, am I correct understanding that this is a very similar model to Go's runtime?
It's got stack switching, and what do you call it? Stackful coroutines is the key part here that allows this interop between the sync and async. So when you need sync async interop, yes, we need those fibers.
And
But I guess we're unlike Go in that we're not forcing. Go routines are both parallel and concurrent, as in they're threads and they're not just fibers, right? They're little lightweight threads. So we're not, it bundles two things together that we're decoupling and saying, no, we're just giving you the fibers, but we're not making anything run, in parallel, which adds a whole new world of weak memory models and all that stuff.
Dave is asking, the adapter is responsible for maintaining a backlog queue of attempted but postponed calls, right? Is that log the place where it can happen? If C2 keeps attempting new calls without expecting back pressure?
That's a great question and a good one to ask. Fortunately, the caller now has a resource on its own books, which is the call index in its own table. So it's C2's backlog that's now filling up. It is C2's responsibility is not to C2. So C2 can know, oh, I've got 1,000 calls queued up. I should stop issuing them now because C2 knows about it. So it lets C2, it's now C2's problem to exert back pressure on C2's caller further up.
Also, says, separating frequency from capitalism is fascinating when stars grounded. Thank you. And my question was, that you said both calling the second blocking call in C1 and calling the callback in C2 would be valid interleavings.
Mhm.
It seems to me like that might be something we would actually want to decide which one the runtime should do there, because otherwise that is a very clear source of different behavior.
Yeah, so it's a question of how much should the design deterministically specify a scheduling when the inputs to that decision are themselves, deterministic enough. There's an inherent amount of non-determinacy just in the system, but it is a question of, are there certain cases where, because as you know very well, like web browser in some cases cares very much about precise interleavings of like the microtask queue. So yeah, we will probably want to, the parts of the schedule of this, fundamentally this means the component model needs to have a little scheduling out, like spec loop that says, knows the state of various tasks and says, okay, you're going to run now. Parts of that scheduler loop will say like non-deterministically select one of these things based on IO completion. And the other part will say like, because this thing's done, the next thing I will do with this thing. So that is a choice we will have to make.
That's exactly the microtask queue and task queue in browsers is one system, and then at some point implemented a flat layer, and still I have solid memories of having to reverse engineer these kinds of decisions made in the flat layer to be bug compatible.
Yeah.
And not all things that look like they might be IO are actually IO. They might bottom out in these kinds of decisions.
Yeah, I think you're right.
We'll want to try to do that. Also, chaos mode's gonna be valuable testing here.
Quick question. There is like a deterministic profile for the core WASM, and the idea that the component model will be able to do such a thing that involves saying you don't have a complete choice that profile will have an answer to it.
Yeah. What happens with deterministic profile is a fun question. Part of it is you're fundamentally calling out to the host. So we could say if the host is going to give you a deterministic result of bytes, we could sort of maybe attempt to say deterministically how it gets chunked and how those chunks get delivered and something, but it does start to get fuzzy.
Just saying, or asking if we're doing stateful coroutines, what do we expect implications would be for resource usage? I'm guessing we're trading off some memory efficiency to support data.
Yeah, I think they can be implemented rather efficiently and also pay as you go, like you know, doesn't have to have a significant footprint in the runtime if you're not actively suspending synchronous calls from asynchronous code, which is the case where this arises. But we're not forcing stateful coroutines when you don't fundamentally need it. Because like if you're just doing Rust composed with Rust or synchronous code composed with synchronous code, you don't need them. It only shows up in this scenario. And it's that fused lowering lifting adapter that sees both sides and says, ah, I need this because I'm bridging a gap here.
I guess if your language supports stackless async, then should very much make use of that. If it doesn't, it's going to be bad.
Yes, that's the right way to phrase it. This is the best we can do given that constraint. The other alternative is you failed to compose, which is worse, I think. Thanks for reading all the questions. Is the queue empty?
That's it for me.
All right.
Sorry, one.
Yeah.
The JS integration, like, when it integrates with the promise integration or promise proposal, is the idea that that would be the sync post case that you described when async will sync, where it would be using so if you've got a Blazon that is calling a JS promise integration, and you're calling that Blazon from a async component, sorry. Yeah, so you've got an interface boundary that's calling out a promise. Is that the only case where the host is going to be basically suspending? Otherwise, any other sync function to the host would always still be sync. It's just a synchronous function. So it's we do the coloring on that host level.
Yeah, like if the host is able to do a synchronous call without needing a promise, then you won't
Can
need.
you repeat maybe with the mic? But
Oh, sure. So in this example of mixed composition, the host get call is effectively triggering the async process. And so I was just saying in a sort of JavaScript integration context where that's a JavaScript function, that would only ever happen when it's a promise integration using the promise spec or the other.
Well, we can do even better because if it's an async component, we can have future or stream integrate with the JavaScript future or stream. So the host call isn't even sync, it's async. So we don't even need that. We don't need JSPI. We just, you give me a promise on the JS side and I just return to the async caller with that promise wrapped up into the call index, like by the JS API
Right,
magic.
so it could be either JSPI if you're going trampolining, or it could be a direct native promise, or some other kind of fallback pattern could be wrapped that you have some kind of post rule, provided you can integrate that basically.
Yeah, roughly. We'll have a lot more details to talk about, but yes, I think if you're an async language, like Rust async, you can call promises now, and there will be no fibering. The promises will kind of flow through. Yeah, because we now have a clear high level way to talk about that in a way that allows the native JS promise to be bound to this in this, call index in this case. Yeah. 10 minutes left. All right. Well, there's a lot more design lower levels, but I'm glad I got through this thing. I would like to switch gears to Joel now, because Joel did a really cool thing, and I'd like to let Joel talk about that. So maybe I'll stop sharing, and maybe Joel can take over and start sharing.
Yeah.
Right.
Hey, Jill, I gotta give you superpowers. 1 second. All right, you have the power.
Thank you very much. Let's see.
Will you publish?
You can make it public now.
Yeah.
in the meantime, Jan is asking those slides be published.
Yeah, happy to. We can put it in the Zoom chat.
All right. So hi, everybody. My name's Joel. Thank you very much, Luke for teeing this up. Yeah, so I posted this in the WASI in the Bytecode Alliance Zulip yesterday or the day before. But this is a project I've been working on for the past week and a half and actually thinking about for the past couple of months because I, like Luke, am very excited about async and want to see what the developer experience in particular might look like. I don't know about you, but looking at these diagrams of control flow can be very abstract, and understanding how all these canon built-ins fit together can be sort of difficult to put together and connect with sort of real-world problems that developers might be solving. And Luke got into that a little bit with some of the HTTP examples, but I wanted to kind of take this opportunity to both introduce this project that I've been working on and also show some examples that work today that you can actually run today, and hopefully we'll give you a taste of what this would look like in Rust, and if you squint, maybe similarly to any language that has sort of this async await paradigm, such as JavaScript, Python's async IO, .NET, and so on. So I'll at some point I'll put a link into the chat, but this is it's called I sync, you sync, we all sync for async. We can come up with a more boring name if we make this more efficient or more official at some point, but I thought that was kind of fun. And so essentially there's two goals here. One is to provide real world implementation feedback on this whole async design and implementation project that we're embarking on. And the other is to provide a sort of polyfill that developers can play with today and going forward while they're waiting for preview 3 and the real async. And in short, we're trying to create that developer experience while minimizing the disruption and to the ecosystem in terms of tools, and adding all these canon ops and lifting and lowering, which of course is going to touch a lot of things, going to take a lot of work. I wanted to see how much we could do without doing any of that while touching as few tools as possible. And so I made my focus WIT bindgen and WASM time WIT bindgen to create sort of as idiomatic as possible bindings that resemble what preview 3 bindings would look like, while leaning heavily on code generation rather than component model ABI changes and WIT changes. And so I'm gonna, we can dig in later if there's time and there's interest. But I wanted to kind of start by showing a couple of examples of what this would look like from the guest perspective. So if you're familiar with Cargo Component or the lower level WIT bindgen generator for Rust, hopefully this will look somewhat familiar. But essentially, we're using WIT bindgen just like we normally would, telling what world we want to generate bindings for and specifying which type we want to implement the exports for using. But we added this new ISIS-WASFA flag that essentially tells it, I don't want just normal synchronous bindings, I want asynchronous bindings to this WIT world. And what that produces gives us the ability to export an async trait or implement an async trait that exports a function that implements a function that the host can call asynchronously. And we can see here kind of a cool thing where we're now awaiting a preview 2 pollable produced via the subscribe duration function, just in the most natural way possible. Like this is as idiomatic, async Rust as you could imagine, and this is composable. I could do several of these in parallel and await all of them. You could do an outbound HTTP request and add a timeout to it, rather than kind of the rigmarole that you have to go through in preview 2, and it just works. There's no need to call the poll function. Instead, the host is your executor. So the host is going to multiplex incoming IO as necessary. So that's kind of cool. And then, of course, finally, we're doing a host call itself that's asynchronous, and the bindings kind of take care of the details of how that works behind the scenes. And now for a more complicated example, we can start to look at what a WASI Preview 3 HTTP service might look like. And this kind of goes back to some of the slides that Luke started out with in terms of like what does that elegant, beautiful, request response control flow look like, in Preview 3. And this tries to essentially, this might actually be exactly what this would look like. Oh, well, no, I take that back. I'm using a record to represent requests and responses here instead of a resource. So not exactly, but in spirit, it's the same idea. And so we can look at this control flow and see a couple of things I would note. First of all, we're returning a response immediately before we've and the goal here. This is sort of an echo thing where we're basically streaming in the request body and streaming it right back out as the response body. And what we do is we actually do a spawn. This is kind of like a Tokyo spawn if you're familiar with the Rust ecosystem. But we're spawning this task so that we can return that response, which in the real component model would involve that canon task return call. But in this case, we're kind of, the implementation obviously differs because we don't have that yet. But the developer experience remains the same, which is we spawn this task, which handles the piping of the request input to the response output, and we can return the response before that finishes. And so the piping could take as long as it needs to. And then finally, I want to point out a middleware example. So we just saw that service. Imagine that's business logic that's doing something more than just echoing. And now we can actually add some transparent middleware. And this is the composition aspect. And this works today using a very lightly modified version of WASM Compose. And so this middleware is responsible for handling request body decompression and response body compression, and doing it transparently so that the business logic doesn't need to worry about it. And this for me has been sort of the holy grail of async IO composition. We're streaming both directions. And so what we do is, we basically take that request that we got from the host, we we basically replace the body stream with a pipe that we're going to, do our decoding with, and then when we get and then we're going to basically call into the other component, into the business logic right here. We're going to get a response back from that, and then we're going to replace the body again with a transparently decoded, encoded compression of the body that we were given, all using streaming, all asynchronous. Again, using the spawn primitive. Any questions on that?
Roman?
Yes, I have a question. So in this, so do you essentially just pull in the bindings? So do you generate essentially a wrapper or all within the bindings, or is that working some different way?
Yeah, so there's in addition to the modified bindings, there are guest and host support libraries called ISIS-WASFA guest and ISIS-WASFA host, and they're responsible for kind of doing the low-level machinery to kind of drive all this. And so the host, if you actually, let's actually take a look at the test code here and see kind of what that looks like when you're actually doing an embedding here. So let's go actually, yeah, let's take a look at this. So the behind the scenes, when we call, it's not the component. When we call into the guest from the host, now this is the host code here. It looks very exactly like what it looks like today. If you're familiar with kind of the async API for WASM time and then the generated code from WASM time with bindgen. So in this case, you're not exposed. There is actually this extra step that's a detail that calls into the support library that has to do, it's some boilerplate that we need to kind of set up this thing. But otherwise, you're just calling this, and this will drive, this call right here will drive the event loop that Luke was talking about, and actually pull the guest multiple times. So although this looks like just a single call, it actually results in multiple calls into the guest in order to kind of, basically say, okay, the guest tells us we're not ready. Okay, we'll wait for any host tasks that were produced by that call to the guest. When they become ready, then we'll call back into the guest, get the response, get the final result, and then pass it back to this top level. And that becomes a little bit more explicit down here when we kind of get into the middleware, where we're actually doing this poll loop thing, where we actually have to drive the event loop after we got returned the response from the initial call, because again, it's sort of like task return produced a result, and so we return control back to this embedding here, but now we still need to drive that streaming, the request response streaming that happens, and that's how this happens. That's where we do that here. And so then we're basically waiting for that response body to finish streaming. We're using a future select so that we can do both things at the same time, both drive the event loop and read from the response body that's being produced by the guest. Anything else?
All I see are a lot of head nods and thoughts that this is really cool.
Cool. Thanks, guys.
Thank you. That was awesome. All right, folks, let's take a 15. Oh, well, are there any other questions? Well, I'll pause for one more second. Any questions? Okay, let's take a 15-minute break and come back here, let's say 10:40. And by 10:45, we'll have time to get in maybe one, but possibly two of the top graded sessions. And I figure we'll do that all together. And then when we come back from lunch at 1:30, we will be running effectively two different Zoom meetings, two different breakouts at the same time, so that we can get through all the different discussions. So see you back here at 10:40. Thank you. Hello, we're back from break. I am still 5 minutes off on my usual estimates, which might be how the rest of the day goes. Because we're gonna be running breakout sessions for the rest of the day. I sorted, with the help of Taylor, into two different groups for kind of, these two different tracks, and I tried to put like tracks together. And then we also have a stack of potential topics if we move faster than what I estimated each topic will take. And since these were gut check estimates, I expect them to be wildly inaccurate. So it's going to be up to the chairs to try to moderate discussion and either end topics once discussion's kind of slowing up and move on to the next one. And I do ask that if you put the sticky on the board to please be there for that session. That really helps, and you're going to effectively kind of help us be the leader of it. So Karen is going to be online on the other Zoom, and I will be in whichever one she's not in, trying to help run some of these. However, we've got some time before lunch, so I figured the two top-rated sessions should happen before lunch, and we'll just do that all together. So we're not going to run them simultaneously. I shall zoom in. And these felt similar, if not the same. I'm not sure, actually. Who added these? Raise your hand. Who added Bit Package Developer Experience? Hey, okay. Lan, okay. Lan, are you back from break?
Yep. That's how I raised my hand.
Okay. Oh, I'm sorry. Thank you. You did. And who added component pooling developer experience? DevX? Excellent. Ryan in the room. Okay. Do you guys feel that these are same or different?
Different but related.
Yeah. Okay, good. All right. So Lan, do you mind describing what you were thinking about talking about, some of the problems? And let's give this, at least 15 minutes, because then we'll give at least 15 minutes for the other related topic. And then once we're done chatting, we'll break for lunch. Do you mind leading the discussion?
I will at least introduce it. I have some congestion that makes it hard to talk for a long time. So this came out of over the past few weeks, trying to really push toward getting a package registry that did sort of minimum viable, useful packagey stuff. And what I sort of started to realize is that we were jumping ahead a step. We were jumping over the part where you can use local packages usefully, or you can use packages in just Git repos usefully. And I think so that's sort of the bulk of this discussion I want to have is about that, about how, if we just assume that there is some registry, ignoring exactly how it works, or even if there's no registry and we used something like Git submodules, which I don't think anyone wants the solution to be, but ignoring how sort of the technical details of how these packages are shared, what do we actually want the developer experience to be of package reuse? And this, I think we can mostly scope this to WIT, but the same questions would come up for shared components, the adapter as being sort of the first major example of that. So yeah, this is a little bit of a technical discussion of like, do we want to keep copies of the WITs and update them in many different places? Do we want WIT files to have one home and be sort of lazily initialized into build directories where they're needed? That sort of cluster of questions and technical opinions is what I'm trying to at least come up with some answers to that today, if possible.
Who has some thoughts on this? And it could just be in the form of questions. That's okay too.
So as a little bit of background to talk just a little more, we currently not only copy WITs between repositories, but also between directories in a single crate. So I guess the very first problem to solve maybe is, how can we have one, not copy at least WIT files within the wasmtime repository? Like that, I guess, is the most concrete problem to solve.
Oh, go ahead, Roman.
I remember some time ago, we talked about, like, not necessarily a solution of the problem, at least like, the first step there is that you want to code, let's say, with packages as wasm. So essentially, instead of a WIT directory, we have a single file, would have all the WIT definitions in it, like all the type information in it. I believe we talked about something like that before, right? So it will be just a single file that will need to put somewhere, or rather, single binary, which could be embedded somewhere. That could already simplify this issue.
So like a binary being a WASM component in this case.
Binary being actually all the WIT, right? So all the packages, all the type of information that actually, the definition of all the interfaces and whatnot. So it doesn't actually have the implementation, just the types, right?
Well, it's interesting in terms of we have duplication here in terms of you're literally textually copying things, and that encourages us to edit them because we can. That's a problem. We could also WASM encode it, which would solve that aspect. But we also have duplication because as part of the crate publication process, we've got 2 crates that need it. They both got to have the actual stuff, which means that when we publish the crates, we have to have 2 copies. So I'm not actually sure we can get away from having 2 copies of stuff in the wasmtime tree. At the same time, we should definitely move away from storing textual files if we are at all encouraged to edit. We should have something automatically managed, something binary included. And that was always sort of punted as some sort of WIT depth style tool, but I don't really know the status of that myself.
We have a WIT tool that's currently out of the car component project that enables you to basically point out a WIT package locally that's represented in text, encode it into binary, and push it up to a Ward registry, and soon potentially even an OCI based registry. And then also reference any dependencies of that package also from the registry as just references to package names and versions. So that tooling exists with the hope that we can make use of this from the WASI repository's CI process to push these up to a central location and consume those in sort of a natural tunnel-based way of referencing those packages as dependencies. But yeah, that hasn't been widely adopted yet because the Ward registry doesn't exist yet. So, but that tool exists. And it can output with just a WIT build command a WASM file representing that package.
So one of the reasons.
Will you tell me oh, go ahead, Lan.
One of the reasons I wanted to avoid talking about the registry in particular is that I think the problem for a lot of people in the room is that we need to solve this problem for the source, like the source of truth of these things, before we can solve the problem for downstream consumers of it. And the source of truth doesn't want to pull from a package registry probably because it is the source of that package, like the source of the contents of that registry. So I'm happy to discuss registries also, but I feel like there's a bootstrapping problem where if we don't have tooling that can solve the source of the packages, then we definitely aren't going to be able to have tooling that can consume the packages. Like it seems like a dependency problem.
Peter, would the tool that you suggested work well for WASI? I think that's what you said, is that it's effectively designed for the WASI repo, aka the source of truth. Is that now today the WASI repos use one tool, WIT ABI up to date, right? It uses WIT binding to generate everything. Are you suggesting that there's something that we can do here inside our GitHub action to publish it? We would have a TOML. It would say what version we're basically publishing for the WIT package. And then that would publish it somewhere. And if it's OCI compliant, we could also publish it to, let's say, the GitHub packages OCI. And then you would see that effectively as a release when you go to the WASI project page. Um,
I think there's like these two distinct elements of this, where on the one hand, like, I think that's gonna be a really useful thing for us to be doing to make these interfaces available to, like, once again, to downstream consumers, this kind of tool, like taking what's in those repos and exporting them for use in like dev tooling and such. And then it sounds like there's a separate problem of like the interfaces that are available like in the Wasm Time's own repo, where it probably, that build process probably doesn't want to be dependent on a registry. And the way things are packaged maybe means that you can't have it be dependent on a registry. Maybe it was what Alex was saying, was understanding. So there's like almost two different sides of the problem here. And one of them sounds almost like very much a Git submodule kind of style solution would be what I would expect. One of them sounds like using a real registry is what I would expect.
Really, but I don't, I agree, there's two separate problems here, the discovery problem and, browsing and everything is a separate swim lane, but on the inclusion problem, I don't understand. I know Git submodules are gnarly and everybody hates them, but this is a solved problem. I mean, it would give you, dependency, give you version control. It would let you, tie yourself to an upstream source that you could track over time. It works today, so we don't actually have to invent anything. We can move on and solve other hard problems. There's a million things on the board that we need to do.
And Wasm Time itself already has submodules. This is it's a sort of a question of like, is the obvious answer here just for us to extend that approach to the wits in the WASI repos? And then,
Like maybe just an agreed upon convention that in the root of your folder, there's, in the root of a project, there is like some standard way of reporting with your dependencies would give you the ability to not have them nested throughout a whole project to discourage repeated imports or something. But then again, you might have a project that imports multiple different versions of the same interface. I don't know. So maybe you do want to allow, I don't know,
So such a tool does exist. We use wit deps in one case, in a lot of places. And then we also use relative paths when using wit dep so that you have one thing that you're pointing to. That works fairly well, but it's not tightly integrated into what you're doing from, like, let's say you have like Wasm Time, a workspace driven cargo system. And it also sounds like another such tool exists, which is what Peter was saying, which I wasn't aware of, but would solve this. Like, the thing that we want to solve is that folks don't edit text files that are there sitting in their repo that they see, because they can, and it's easy to drift because you're like, I'm just gonna edit this one thing because it's gonna take longer to get it upstream, and then you get in a bad place.
So the case of Wasm Time not wanting to depend on an upstream registry to pull this stuff from, it's certainly possible we could just have the Wasm binary sitting there that represents the entire package that we're referencing from WASI and generate bindings from it. Wit binding doesn't currently support binary. That's something that Cargo component internally does when you're referencing binary wit packages. But there's no reason why it couldn't. That's fairly straightforward. But for me, the packaging and publishing of wit packages is primarily around the developer experience for offering guest components. And how we solve this for Wasm Time should make just sense for Wasm Time, and get someone to seem like a fine solution to me. That doesn't really involve much overhead. But yeah, those are kind of two separate things to me. The binary publishing packages are guest one offering related for the most part. That underlying tooling should find those, respect them, and integrate them in ways that are fairly transparent to users. Yeah.
So I have actually two things. So first, like with depths was never meant to be like at least as this today, right? It's just a temporary solution, like to like MVC to solve a very immediate problem that we wanted to get dependencies, and they have to be all duplicated. So it's very simple thing, just not really meant for general, like that's not what such a tool should look like, right? So I think like more importantly, if you see like we have to first get consensus on like, is Wasm Time the source of truth for say WASI IO, or is WASI IO repository the source of truth, which then Wasm Time imports? Because that's like the first question we have, and these kind of things, like these kind of packages, right? So that's the first question we have to answer. And then once we have answer there, then we can actually know, well, how do we actually establish those?
But I think the tempting answer is for, some WASI repo, whether it's each proposal's own repos, or maybe we make a repo somewhere that is like the released things of those packages somewhere, so that there's only one thing to pull from. But either way, some WASI repo source of truth, and then using, the WIT tooling that Peter made to pull that to developers, and using submodules to pull it to WASM time. Ultimately, I don't think there's a world where we don't choose to have WASI itself be its own source of truth.
The WebAssembly/WASI repo has the voted on released preview 2 WITs.
Wonderful. So then it wouldn't have to necessarily have like submodules for each thing. Even you could have, maybe just pull that one in as the source of truth for the release
You
status.
go under preview 2. I don't know who's driving the machine right now, but
It's me.
okay. Yeah, so I put them there with that rough intention. Though of course we didn't, do any steps from there. I just we do need to have a canonical place for them. There's another element of this, which is the docs in various of these WITs are not perfect right now, and we're going to accept changes to those. And so how do we update that? Or don't have to dive into that now. I just want people to know that that's something we will address, of changes to the docs that don't result in changes to the meaningful part of the definition.
I think a similar question is where the development on WASI 2.1 WITs will happen. I assume that like the current like default answer is that will still happen in WASM time. Doesn't have to be the answer, but it seems like the default right now.
I mean, it certainly has been for a long time, and yeah, I feel like we have to. There's pieces of that tooling puzzle I don't know the answer to right now that we just need to experiment with. I don't know. Alex, do you have thoughts on that?
Yeah, kind of, I believe, I agree with Peter in the sense that the WASM time / the embedder side of this is a little bit separable from like the guest authoring side, but from the WASM time side, I think that we should have actually what Peter was also saying, which is sort of a published release for WASM time or WASI. So WASI has like tag releases and then the GitHub page, or sorry, Bailey was selling this, but basically they're not WASMs, which is like the compiled version of everything. And the ideal workflow I want to take one of those, drop WASM time and forget about it. So we have 2 of those in WASM time for our own weird reasons, but that way we can't edit anything and all that stuff. So we need to update the tooling to be able to ingest WASMs, and that's kind of it. And then also update the tooling to ingest WASMs, and then additionally update the WASI release process to publish WASMs that are compiled together. And technically, we could have like a WASI-IO WASM, a WASI file system WASM, all that. For now, I think we just shove it all in one. And that's just kind of one artifact. You can just drop the project, use WASI.
Yeah, I would like to do that. And then the question of how do we develop 0.2.1 is, well, there's just another one of those that we, update manually. We use some tool to update manually the current checked-in version. And we point that at either a Git commit of upstream or just files locally in your file system. I don't know the answer to that yet.
What if we had a branch in that WASI repo that just had the WASMs built from like a release sort of branch, just to hold those files and make it so that all WASM time needs to do to update its WASMs is pull and update the submodule for that branch that has the WASMs in it. And then if to release new things, to have new whatevers, you just add stuff to that branch, and there we are.
Well, the idea, I don't think that particularly solves it, because we need to simultaneously have the 020 release and then 021-dev. Right? So there's not just one version in the WASM time tree starting really soon. There's whatever the published ones, the done ones are, plus whatever's the work in progress.
I mean, we just have both, right? Like it could have its own sort of release candidate prototype version of interfaces in tree, and actually like pull in the stuff that is published, And then things would move from your release candidate prototyping in Wasm-Time versions, and you just eventually switch over to using the version that's published.
I hate this.
But I don't think that is, I don't think we want to have submodules for that. That's not, I don't feel like that's the right tool to like, to have many different versions of a thing is like many different checkouts of the same submodule at different versions. That seems.
I was saying that the release branch, you just add a new commit to that branch that adds the new file to it, and everybody would just submodule in the quote release branch or whatever. And that would mean that you'd get all of the files for historical releases.
I was thinking of something slightly different, but very similar, in that I was thinking we could have some type of branch. I wouldn't call it a release branch. I don't like creating those until it's like released and then you put patches on it. That's just like a little silly nit, but I was thinking that we would have like an 021 representative branch at some point. But it can also just be a dev branch, right? And then as we tag it, a tag would create the .wasm that we're talking about slurping into all these other reference impls.
Yeah, I'm much more in favor of having like Git releases are a separate thing than files present in a branch. And making the files present in a branch just seems like a really long way of like it's just going to make we're basically going to duplicate the process of having a registry by maintaining a Git branch. So it doesn't really seem appealing to me.
So in the
It
interest,
still works out for, oh, sorry.
well, I was just going to say, in the interest of time, it sounds like there are some questions we're not going to be able to answer today, but it does feel like there is some consensus on creating a binary artifact from snapshots of these WIT dependency trees and using those as the primary sort of distribution mechanism across repos. Does that sound right to everyone?
Yes, I think that's.
That is a good outcome from this session for me personally.
That sounds good to me.
It seems like we want to have a manifest of some kind in Wasm-Time repository, right? Which would then define a source of this artifact, would then be pulled at build time.
I think that's true, but I also think it's fair to separate that out in the sense of that's like I can see sort of the registry-based tooling, sort of a manifest automatic downloading, just that we're not manually copying files around. That sucks, but I think it's fine for us to do it for a while in the sense of I think we can easily separate the two tracks of like getting to the ideal state of Wasm-Time is okay to do the same. Basically, I think the higher we get is getting away from the fact that we can edit files in Wasm-Time. We've done that a lot, and we're still tempted to do that. So getting the binary artifacts is probably step one. And I definitely would not want to block getting binary artifacts and having a manifest or anything, but if we could do it at the same time, though, it's fine.
Do you want to check in the artifacts then?
Yeah. That's what I would imagine.
Okay.
I'm hoping they're small.
Ryan, do you have the second part of this discussion here? I'm gonna go way back out. And back in. Component tooling dev experience. This is related but separate. I'm guessing you're talking more on the dev, like the guest side.
That we have people now that just working on getting things to work in general, which is great. Now they're more or less working. But there are many cases where they work if you know exactly how to treat them, and if you don't, then good luck. You have to be maintainer of the tool in order to really know how to use them. And I think everybody recognizes that. But I think the classic thing in open source is to say, well, Ryan, if you think that it's not good, go ahead and contribute and make it better, which is fair. Okay, I'll try and do that as much as I can. But I'm gonna put my foot down and say that's also not good enough. And I think that we should collectively agree that we want to hold ourselves to a higher standard of dev experience, and make sure that every tool that we have has great error messages, good documentation, good help menus, is intuitive to use, and that we're open to feedback about that. So I don't really, maybe this doesn't need to be a long discussion. And I imagine that nobody here is gonna disagree with what I just said. But what can we actually do about it? How do we actually affect change so that people who are not familiar with the ecosystem can use the tools in a good way?
I'd like to call out Dan's WASI-HTTP Hello World, repository. I think it's a great example of, I think what we should do is just have this like a simple repository, like simple quick start of people like, okay, I want to build something that does HTTP. Here you go, just run 2 commands and it works, right? Just do cargo component build, bottom time serve, and you're done. That would be great if we perhaps, like we develop WASI Cloud, and for each interface, perhaps we should have a similar like quick start, or perhaps a combination, like a repository with a series of examples of how to start WASI Cloud interfaces.
I can also add, when I set up Hello WASI HTTP, we had to fix a lot of bugs to even make that repository work at all. So like the process of like, let's set up a tutorial. This should be easy to do. You should have a process for doing this. And like started doing it like, oh, this doesn't work. Okay, let's fix that. The process of like working that through, we're like, oh, I don't know how to use this tool. I gotta figure this out. The process of making those tutorials actually really drives like a user story right there. So I would encourage people to set up more of those. Like find the thing you should think you should be possible to do. And if you have the ability to figure out how to do it, then like figure out all the steps along the way, what was hard, what didn't make sense, what took learning, and then record those things and let's push those things out.
Whenever you encounter an error message that's not actionable, file an issue. That should be our just go-to stance. If there's a confusing error message anywhere in the stack, that needs to be an issue. Like I just had one this morning of someone that was trying to do cargo component build with multiple worlds, and it just said couldn't select the right world. Well, that doesn't help you. So I asked the user, and they did, and I'll fix it to make more actionable. That should be our default stance in all our errors.
So one thing I also want, like, there's a couple of gnarly error messages that I've talked with people about how we would fix that. You know, the usual response to that is, ooh, that's gonna be a tough one because there's a lot of, technically that's not necessarily the right phrase, but the way things have been currently architected, it's not quite, doesn't make it easy to fix that bug. And so it's not about, okay, we just need to fix the bug and somebody do the work. There's significant investment that needs to happen in order to change the code base to make fixing those bugs easier in the future. And that's also a question of, we're not going to get a new feature out of that. In fact, when we first do it, it's purely going to be a refactor that probably might introduce bugs. How do we, this is the classic software engineering thing, but how do we prioritize that, especially in a distributed group like this, where for a lot of tools, we have kind of silos of knowledge where there are people who know how it works and they're busy enough with new features and, moving things along. What do we do about that?
I really like what VS Code did in this case, and I realized that was like a lot of Microsoft employees, like if we're being real here. It wasn't quite as much of a distributed context as us, but if you look at the contribution graph when they did this, it was a ton of outside folks. So I think it is a relevant example. And what they did is they decided to have a stabilization iteration where it's like, no, that's our focus. We're gonna come in and we're gonna just burn down stuff as fast as we can. And I think that we should do that. I think that's a great methodology and a good software practice. I'm not gonna say the googly thing here actually, because there are other aspects of that folks don't like. But the idea of being able to come together and have a common goal and have that be the one thing, right? You're not juggling a million other things. You're focused on that one thing. But my question would be, I guess, is it more important to get 021 out now, or well, okay, let me give you a proposal. I think we should have 021, like let's make that be our thing. And then all of this developer experience stuff and all the bugs that we need to fix and the tech debt that'll get introduced by trying to create that 021, it's totally relevant to fixing the developer experience. So we do 021 and then we do a stabilization iteration. But I think to call out what Peter said, the most important thing we can do is also like, let's say what's hard, what's bad, where is it? And you know, I think we're all really good engineers and we really hate filing issues when it comes to like, I don't have an idea here. I just know I don't like it. I get an ick, and I also hate getting issues where they're like, I got an ick. And I'm like, okay, well, that sucks. And that just makes me feel bad because there's nothing I can do about it. But I would say, let's get O2 out, and then let's have an ick session where we just kind of generally say where we feel it. And then collaboratively, I think we can file issues together, right? And just have a bug bash hour-long session where we just try to create that burn down list and then work together to burn it down. Tyler?
Explicitly putting it for that, say like.
Let's put it on the roadmap.
Like milestone ahead, would it probably make it easier for individual companies to prioritize.
I wanted to say is that like cargo component, I think has been a really great example of us seeing that some of these like usability things are actually some of the easiest things to contribute on our site. So we have a lot of really complex technical systems going on here. And like some of these things are harder to jump into than others. We've seen people come into cargo component with say, hey, I want to run cargo component test and run things and contribute that work and talk to us and get that stuff done. I think the really exciting and probably most realistic thing for a lot of those sort of user facing things is that we need to like encourage and support new contributors coming in when they find those problems to then go solve them. Because like I think that's the model that well, we can't magically get more of our own hours, I think, out of the ether, but we can bring more people in and be open to that, facilitate that. You know, like last year there was some talk about like good first issues. And I think as a group we really weren't ready necessarily for that time because there's still a little a lot of work left to do. But now I think we actually are at the point where like maybe it is worth thinking about, you know, labeling some things good first issue and like trying to carve out a little bit of time to mentor people for those things. Because in the long term, that's going to help our stabilization effort a lot, is to have users who are finding the problems be able to fix them. And that should be like a focus direction.
Just as a quick check-in, is there anybody here who's sitting in silence thinking like, this is all well and good, but like, we really gotta get to preview 3 as fast as we can and usability be damned. It's like, we gotta get there. Like, I think that's a legitimate thing to think. I disagree with it, but like, I would like to hear if that's the case, because I think that's a healthy debate we should be having.
I don't think that. I think this is we can parallelize some of I think what needs to precede the implementation of preview 3 is some experimental work like Joel's doing, and then some design work in the component model repo. And while that is in progress, just a small number of people, then there's a lot of this parallelizable work and focusing on these sorts of polish and usability things seems like a great idea. I was also wondering and I know we talked about O2.1 being focused on like April-ish timeframe, but there's also this WASM.io timeframe where presumably a lot of us will be making a big noise about, hey, O2.0 just released, come check it out. I wonder if that's a useful point in time to say what stuff should we have polished in front of WASM.io, so when people show up at various websites on for the first time, having seen a cool WASM.io talk, then it looks nice. Like, should we maybe make a small little burn down list leading up to WASM.io? That's pre O2.1. It's just fix O2.0 or document O2.0 or polish it.
That's a great idea. That's going to be so important, I think, to our success there at that event. You know, I don't want people to we're like, it's great, and we've done it, and we all can run the same component, and it's just so easy. And then people come in and run straight into a brick wall, and they're like, what is this? Yes, we should totally do that. Then in order to facilitate that, maybe we could come up with some big buckets of things that we know are rough, and then spend some of today trying to put a finger on it on what the burn down list would be. Yeah, Michelle.
It also be helpful with around perfect and everything. So it's great to have a call to action at WASM.io for people there, or just, you know, feeling ready, like, okay, if you have an issue, where do you go exactly? And it should be very clear what is that central place for experience issues, because people may not know like which repo to go to exactly or where the problem is. So if there was kind of a central place that we could point people to, I'm not suggesting we create a new place, but just maybe existing place, more like, yeah, go there.
Anything, Ryan?
Yeah, that's great.
That potentially, from a messaging perspective, it's really good to be able to start soon saying, hey, great, if we go to X, make little changes. But Wasm.io, making that happen at least a few weeks after Wasm.io, so the messaging around Wasm.io is 2.0 is out and 2.0 is good and stable. Changes will come to improve things, but this is the stabilization period, and any changes to it are not going to start, they're going to start getting out of whack again immediately. So you now use the 2.1 guest thing, now you use the 2.0 host, and maybe like hunting actually a little bit on to point X to like end of that month or the next month, just to get some breathing room. But then, of course, getting straight to it since the version across the road.
I think just to wrap up, like, I'd like to echo what Tyler said, like, I think just having public commitment that this is a thing that we care about is like a huge step forward and saying that this is the thing we do, and to also try and get in the habit of doing that so that we don't have this, 2.1 clean up and then we just never do it again, but it's something that we constantly think about and have teams about over time of what we want to improve, so that it becomes part of our culture for the entire ecosystem.
I'm moderating. The one thing that I really loved in the CNCF community when I was learning Kubernetes and stuff is that we ran these bug bash sessions where once every 2 weeks, so bi-weekly, we would have like, your SIG CLI chair come in, and Eddie would run through some of our major lists and then talk about, oh, this issue needs to be moved over here, right? And so just watching them talk about, here are the issues that came in, and this is actually where they belong, was amazing for learning what the heck is going on for any of this stuff. And so maybe we could have something that's like bi-weekly for a little while, where we just kind of do an issue wrap up. I would ask though that I have maintainers that volunteer to help do it for a bit. And yeah, just look at what we have, what are our major issues, and talk about it kind of in the open. And I think that'll really help. And we would broadcast that this is a great place to just come and hang and watch and learn. And as we do that, hopefully we also get good docs so that we have landing pages by Wasm.io, like, oh, hey, these are some examples. Here's an FAQ for like the types of issues that you see and where they need to be sent. That was, yeah, I forgot Eddie's last name, but SIG CLI still does this. And they've been doing it for several years now. Really wonderful.
With making this more formal, like, so Intel has the TikTok fabrication process where they sort of go back and forth between improving architecture and I don't know, refactoring, I think would be a good way to characterize it. Perhaps as we get into a more regular release cadence, we can think about going back and forth between, introducing new features and improving tooling, and sort of making it more a regular part of our process could address concerns about not just having this be a one-off.
It's also easier to write docs and stuff when everything's not changing out from under you. We're talking about what we just finished implementing, and now we can target it and document it, now that it is a defined thing. That's a good point. I like it.
Do you have any other thoughts online?
One more small thought,
Please.
is I think a lot of this also applies to the internal development cycle as well. Like, folks want to contribute to WASM or JCO or some of the tooling. Like, how can we start improving that developer experience we can onboard more people into the ecosystem? That's always hard to do because you just want to move as fast as you can, but I think in the long run, it really yields dividends. I think often about member of the Rusty developer guidebook, which is huge. Like, an anytime I ever have to touch the compiler, I go to that book. Because I don't do it enough to maintain that knowledge in my head. It's invaluable, and I know lots of others that do that as well. So if we can start building that up as parts of the tooling solidify a bit more and don't change quite as drastically as they have in the past, I think that would yield dividends.
Love it. Thank you for the excellent session. So it's 11:30 now. I'm gonna jump over somewhere in this mirror board. Just kind of been building things. Here we go. So the idea was that potentially we would be back by 1:30 to start kicking things off. I think 1.5 hours was not enough last time, so I'm glad we're gonna get the extra 30 minutes. I think that's probably exactly right. So we're gonna break for lunch and be back here at 1:30 Eastern. And we'll kick off the 2 dual sessions. Thank you. Hey, folks, can you? Yes, you can. Cool. Hey, Karen. Are you there? Hey. All right, I've got the two Zoom setups. I've got two different laptops in the room.
Okay, that works.
And I have the other laptop logged into the Zoom link that Till posted.
Okay, just tell me what you want me to do. Because I only have one laptop. Or I could
Yeah,
probably log on my phone or something.
Kate is gonna run, I imagine with lots of others, but be our main facilitator for this first one at 1:30, which is in a few minutes. And that will be on your Zoom. So basically I'm gonna change the Miro here. Do you have a link to the Miro? Have you seen that?
Nope.
Okay, so that's where a lot of this organization is. Let me, are you on Zulip?
Yeah, I am.
Okay,
I'm
gonna
like in the
Zulip
event
to you.
channel. Okay.
The one I'm currently in? It's in the events.
Oh, it is, okay, great.
Same file as Dan's.
And Karen will be over there in a second.
Okay.
Some applications for developer workflows and stuff. Wow.
It's actions.
Yeah.
Yes, I can hear you. This is the one called us.
Yeah, I think so.
Nope, it's the other way around, Pat.
Sure.
Okay, Karen, I just zooloped it to you, but basically.
Okay, give me a sec. I think I need to log in. Okay, I think I have it open. What should I do now?
So in there, you'll see where I have a section for breakouts.
Can you tell me
There's-
approximately where it is on this page? Okay.
Sorry that I'm kind of crazy. It's all the blue towards the bottom.
Okay, got
And
it. Okay.
yeah, so I'm thinking on your Zoom, you will run through starting with documentation with Kate as your in-room facilitator. And then move to shared everything threads, WASI TLS, and async. And I'm
Okay.
gonna stand in the other corner of the room and run this other block with all the WASI stuff. And I figure that makes sense because I know WASI. And generally, the ask is to try to, keep the conversation moving, put a pin in it when it's time. I don't want to be too like stringent about it, if the discussion's really good and people are really into it, then it doesn't need to be exactly 15 minutes or anything like that, right? And I baked in an extra flex of 30 minutes. So all of this is supposed to end at 3:30 and then we're gonna take a break.
Okay. I'm
You have
assuming everyone,
Joel
does
has
everyone know what they're assigned to?
kinda.
Okay.
Joel, yes. For yours, yes. For mine, no.
Okay.
But for yours, shared everything linking, WASI TLS, and async are all Joel. And
Okay.
then awesome time debug session, Nick is ready for that too.
Okay. All right. So Kate, Joel, and then Nick, right?
Exactly.
Okay,
Then if
cool.
you have time, right, like if you get through those pretty quick, I put two others
Mhm.
below the line that you can pull in. And
Okay,
if you
got
if you
it.
pull them in, will you update the mirror so people know that it's happening?
Okay.
And the way to do that is just
But this
move the line
should,
down.
okay, and this should end at 3, right? So do I just send everyone back to this room at 3?
Exactly, at 3:30.
3:30, okay. All right.
You should have time, but I also think that, there might be some good discussion, so.
Okay, cool.
And
All right.
you-
So I'm just gonna
are you
shepherd
okay with-
people through these different sessions, right?
Yeah, I'm gonna drop the
like,
Zoom link in the
okay.
mirror now.
Okay. All right, I'm gonna hop on over and then 3:30, I'm gonna push everyone back to this room.
Sounds great.
Okay. I guess just ping me on Zoom if you need me because I am going to close this Zoom room now.
Okay, I will. And I can also just walk to the other end of the room and talk to you.
Oh, I see. Okay, yeah. All right. Okay. All right. Well, I'm gonna jump off this room though, but yeah.
Okay,
All right.
bye.
Bye.
Is she on the other one?
She's on the other one,
Okay, great. And you're staying here then?
and I'm staying here.
Super, all right.
Right, and
Alrighty, 132. All right, that was pretty close. I am going to here.
That is what I did.
Resume share.
Spike on that.
Now we are here. Hey, folks that are joining online, there's 2 Zooms. We're gonna get started shortly in the next minute. Walking through the ones on the right and the ones on the right hand side here, starting with how do we bound WASI? That's gonna be Pat and I. Pat, are you here with me? I hope you are.
PCR made a lot of sense.
All right, I'm gonna go get Pat in the other Zoom, and then I will be right back.
First waypoint, which all registries, it just involves like something. But yeah, I don't have a strong opinion on the.
Guys, there's hummus and cheese and fruit.
I did.
So it's been connected to what files it's like natively implemented. It might be special, but. That's the much where it's like, really want it, then you just name it. It's never proven to that's all it takes. So, yeah. Now that we addressed the whole thing, those guys have.
I'll say to you and then I'll.
Yeah, it seems like I just. I mean, it was not.
Yep, if we publish both GHR and the Alliance for registry, that's.
Back here, now there are 2 Zooms. There's, and both links are posted in the mirror board for each side. These are divided up basically like topics and also mostly in the order of what was, people have the most interest in. So that's basically how it's broken down. And the times are a rough estimate. I have not seen us to stay right on, but I think we have a lot of topics to get through. So trying to aim it in a way that it's a quick hitter is really nice. And I'm gonna walk over to the other corner of the room. Hi, Karen. Karen's running this one. And kick it off down here with the WASI stuff. And if you're physically in a room, go that way if you want to be in that part of it, and come this way if you want to be on some of these WASI topics. So I forgot I had this up. Ready, set, go. All right. How do we bound WASI? Are you there, Pat?
Yes, I'm here.
Okay, cool. All right.
I don't have a video view of anybody. I just have the shared screen.
That's my fault. Hello.
Okay. Yeah, no, I was just letting you know.
Do you see me now?
Yep.
Okay. I guess I will pull up a chair and take notes for the most part, but I'm gonna stop my share actually so we can just see each other.
Yeah, I just pinned that. Okay, Willa, go lay down. Hi.
All right. So, hey, WASI interested folks, and feel free to drag chairs.
Willa, go lay down.
Might be here for a while, or if you're Pat, take care of your back.
Yeah,
man.
I went and sat on the couch, so sorry I'm slouching, but
Looks cozy.
yeah, I don't really feel like being at my desk.
And generally speaking, these mics have a pretty good range. So, unless you're soft spoken, so Dan, right here, yeah. And then we'll be good. Okay, so will you give the context for why we added the sticky? Pat.
Oh, why we added this sticky? Well, that's a great question. We hear a lot of WASI proposals, right? And I guess one of the concerns we have is that, well, we kind of learned our lesson. We don't want to do things that extend the VM. So that was one that arguably, like, even WASI.io still does kind of out of necessity. But we're gonna work on that. We have a plan for that with the component model. And then I think the question is, well, where do we go from here? Like, what's next, right? There's a bunch of WASI cloud proposals. Are those, serving WASI well to have those be part of it? And how far are we going to go with those? There's things like NN and SQL that we're going to talk more about soon. I think one thought experiment I have as we add in all these WASI Cloud and WASI NN and SQL and so on is the juice worth the squeeze? Meaning, are people going to choose to use this interface over just doing it over sockets? I think, for all the interfaces we have right now, it's like, yeah, absolutely. But that's something I think we should keep an eye on going forwards. And I guess that's all I'll say to introduce that topic.
So is there any rule at the moment, even like a soft one, like what belongs in and what belongs out?
Not really, aside from don't extend the VM. You're only allowed to be doing IO. You're not allowed to be doing things about the VM itself. So that's our way of ruling out threads and backtrace.
Limitations also serves their role here. We want something that only works on one platform or with one vendor.
Yep.
That's like our main criteria.
So the answer is not really, beyond some soft rules.
Trying to think of something absurd and see if it belongs in or out. Like, sorry, my initial thought with all these conversations like this is like, all right, like, can we come up with a bunch of ideas, put some on the outside and put some on the inside, try to derive a rule?
Do your worst.
I don't.
What do you got?
Well, one criteria I've thought about is that so far we're adhering to is we ideally shouldn't be defining interfaces like Ether, where we're just kind of domain engineering. We're finding an existing spec and trying to say, what's the wittification, the appropriate wittification of that? And can we collect domain experts in that existing spec and bring them in to evaluate our WIP? If we can satisfy all those,
So that implies that it's stacks.
somewhere else.
That's a rule.
Well, it's a heuristic. I would say it's not
Now,
a hard rule.
Chart system things, there wasn't exactly, but it did look, I mean, you could say Windows, POSIX, and Mac OS are practically three distinct important specs by just existing, like de facto or. And you kind of took an intersection of them.
Yeah.
Right. And with
Good experts
HCP,
for
there's
yourself.
obviously a spec, and then there's both the platform of, are you doing this on top of sockets or are you doing this on top of fetch? So that was another way of looking at HCP, I think, that was really useful in terms of having two distinct platforms, one of which was based on fetch, I think was really a useful tool in that case.
What about some embedded hardware? What if I want to link a LED WASI? We have a WASI LED GPIO.
I think there are specs in that space, right? I2C and the other one.
Oh, yeah, a whole bunch of.
So yeah, and there's people who are interested in that.
Okay.
The biggest thing that's going on with the people interested in that is that they're grad students. And that doesn't mean that it won't be successful, but it makes me apprehensive because I don't think their incentives are super aligned with long-term success of a software spec in terms of just getting your master's thesis out the door. So what we asked them to do is find a co-champion who is actually an industry engineer. And I think they found someone from Siemens who is willing to be a co-champion, but we haven't really chased it down yet. I don't know the exact status there. I kind of been leaving that to Bailey lately.
And I think there's a difference between, there are engineers that are expert in this and this is their day job and they build businesses around it, but we just don't know who they are. And there are people working in this space, but they happen to be graduate students.
Yes.
It's like I2C is not a domain that's largely built around graduate students.
Right. And that's the thing. It's like if they want to do I2C as an interface, we really want to see that there's a customer for that work. You know, because you can write down a spec, but if no one actually goes and uses it, then it hasn't done any of us any good. Right? So if Siemens is going to,
That's another rule, right?
we're going to
So
make
it's-
this part of the world we
Well,
offer on
yeah,
these
some,
devices.
reasonable definition of care,
Yeah, so
right?
we-
Someone has to care that we have to care about them caring or whatever it is.
So some could be multiple limitations to achieve that, because like, it's one thing to like make a spec, then you have to implement it, and you have to get someone else to implement it.
Well, I think there's even this one tiny degree higher, which we have a difficult time articulating, which is these implementations can't be like toys. They need, previously in the browser world, it was easy, like 3 web views, which is like, those are 3 very meaty implementations used by hundreds of millions of people. Outside the browser, we have too judgmental of who's production and who's, but roughly we want something that like some bar you have to cross of like, yeah, millions of people are going to use this. And this, you really care about security, you really care about longevity, as opposed to like my toy interpreter that I just wrote.
Right.
Yeah.
I think it should be important that they care too, right? The people that are in this market care too. They see some value in what they do. It's a reciprocal. So.
A diabolical case. We were trying to think of what wouldn't be in.
I have a weird one, but go ahead.
Okay, all right. I've been spending the entire time thinking about what my weird one would be. And I was thinking like an API gateway, but like mine that's opinionated, right? Let's say I'm a vendor, like, I don't know, a CEO or something, or you know, what I actually am. And
Real world dialogue.
Yeah, maybe too real.
This is a hypothetical dialogue.
So let's say I built that though, but it's not an industry standard, right? But I run it on all the clouds. I put it in all of the runtimes. I meet our barrier for entry for saying that it has portability requirements, but in the reality, it's a higher level API that doesn't belong as something that's a standardized interface, even though, you know, and I would argue that everybody should be using my software. Everybody will want it. Everybody needs an API gateway, but
I think the lack of that independent standard, kind of pre-existing, that kills that one, right? Or
that's basically the barrier, I think. But that's hard, right? Because not all of these are, we're not always taking exactly the standard. We're saying that there's a standardized thing, and then we're making it fit well in the WASI ecosystem. Exactly, like WASI HTTP is my example for that.
Yeah.
But would our answer to that person be, well, go write a plugin?
It would be. And wouldn't it be great if I could have my own federated registry or my own ecosystem for these things that other people plug in?
Yeah, but I mean, that's like,
you can have code gen, you can have all the things.
we give you the tools to do that.
It's not a
knock
WASI
yourselves
stand, not a
out,
WASI-
right?
WASI
Yeah, you're just on the other side of this vaguely articulated boundary.
And if other people get excited about it, they can build around it too, which is what we saw with WASM Proxy, where people were like, yeah, no, I actually want something like this and I want to build with it. And it's totally okay, I think, for these other ecosystems to exist. I'm like literally copying from Dan's talk at WASM.io, by the way, from almost a year ago now, where you basically said that is literally the goal. We're trying to define what the foundational pieces are, and then these other ecosystems need to evolve out of this.
Right.
That might even motivate those people to do that work, right? Go build a, standard and some other people supporting your diabolical API TM, and then come back and we can maybe have a conversation.
It couldn't be TO, because you signed the WPC, the long-form agreement, everything you bring to the subgroup is not your trademark, right?
Yes.
That would, you would have to be okay relinquishing whatever trademarks and also other IP. That's not or do you consider?
American charging standard.
Oh, yeah, we want that.
Would there be multiple what?
Implementations, like independent implementations, because like if you were a person, you probably would build your own implementation. And like maybe you would also build it to run on top of various clouds in various places. You would all be building it. What WASI would want would be multiple independent implementations.
That's a good call out.
And if it is also somewhat of a fuzzy term, right? But like, could you convince a subgroup, for example, that the independent implementations, not just like, it's my business and I just have all my employees doing this thing for me.
I guess maybe that do in that case is if there, this is an API gateway, there are lots of API gateway companies go out and, as part of like the standards group say like, hey, we're soliciting comments from other API gateway companies.
It's true. And then could you get consensus around your API or instead of us like, well, you get 500 people saying like, you should have this, you should have this, you should have this. Right?
Yeah. But I don't think 2 is enough either.
No.
You know, because what if I got my friends at Capital One that work on Watson Cloud with my friends? That cuts on it.
Independent implementations, right? You just have 2 people saying your implementation is awesome. So
Yeah, I mean, I can see a case of one implementation's a enterprise implementation, the other one's in the CNCF. I'm playing the diabolical game pretty hardcore.
Yeah, I don't think we even need to play the diabolical game that hard. So Dave asked a really good question. Are de facto standards like S3, Redis, PCRE? Well, so S3 is blob store, kind of, right? Redis is key value, kind of.
But we do blob store, we wouldn't do Redis, that would be too specific to them. PCRE is not to with a particular vendor, that's just like an open source definition as far as I'm aware.
Right. Well, so PCRE is actually one that literally is a proposal that we voted to allow some people from WAMR to make a phase 1, and then they have never even touched the template repo. Not that I'm bitter.
Yeah,
But
I think PCRE, as far as scope, I think it would be in scope. I think there's not
Well,
really anything. It's not associated with
PCRE is in scope. I actually think that my rule for saying that PCRE is out of scope is that there is no spec of what PCRE is, and there's no multiple implementations. There is only the PCRE implementation, which frankly is ridden with security problems. So if you wanted to have a regex spec, you basically, the only regex that has a spec and multiple compatible implementations is the ECMAScript regular expressions.
There is a page that they say is the PCRE spec, but it is a description of the implementation.
there's a pointer to the repo or whatever.
More or less.
Right.
Yeah.
That's like saying LLVM has a spec. It's like, well, sure, but
That one seems tricky to me, just because like it's something that is clearly super useful and is widely used. And it's almost assumed to be a spec, even if it doesn't actually have a spec. So maybe this is one of those ones that's like maybe an exception to a rule. I don't know.
well,
Yeah.
There's projects we don't follow it. Right, so we can make up our own totally loosey-goosey specs like file systems. Right,
So
our file system metrics are all over the wall because like Windows.
Yeah.
Right? And other things, but like largely Windows and Unix.
in a world where I have plugins for my runtime, and I have a registry that makes it really easy for me to share my WIT package and my definition for what my spec is, why would I want to go through a standardization process other than to be
Bingo.
first so that everybody likes mine and I don't have to change it to somebody else's?
yeah, it seems like a lot of these, they're looking for the standardization process as a way to win.
I mean, in a sense, that's what standardization is. It's a way to win.
Yeah.
It's a way to achieve agreement for one thing that can win. That's what PCD.
But does it serve us or the ecosystem to pick winners when instead we could say, well, it doesn't really feel like there's a need to have a cross-platform interface to PCRE, and that, different platforms provide different ones, we'll let a winner emerge that way and come back when that's happened.
I mean, this seems to me why it is probably useful to go out and actively solicit feedback from other interested parties. Because if like those interested parties disagree and like they cannot all come to like an agreement about what this should be, then that's a sign in itself that this shouldn't be a thing, right? Maybe.
Yeah, I think the biggest flaw there is getting people to participate, even to the point where they'll disagree, is a pretty high bar. And so right now, by just participating at all, you can kind of.
I think that's hard right now, but I don't. If we are successful, I do not think it will be hard.
Yeah. What I worry about is that if we do things now that make it hard to set that precedent later, like we kind of have to be a bit eager about not doing those, or well, a bit defensive maybe is the word to it, of like.
Can I suggest another diabolical one?
Yes.
Sure. WASI left pad. Why not?
Well, that's just a component. Just use it as a component.
I think our strategy there is to say, like, I don't think anyone would bother, because you gotta, there's a good committee process to go through.
Okay.
And who's gonna spend the time?
That's fair. Like, I don't know what you really have to gain by doing that. So I started with like WASI UUID. And then I was like WASI base 64 and then landed on WASI left pad. So like my question was really like, what is the line for too small? Is the line for too small?
I think we just let natural consequences kick in. Be like, if someone really wants to push this forward to the process, then WASI A64 is someone's thing, then we do that.
Fair enough.
I don't know. I feel like we have enough bad actors that that we might just be trolled that way. Like that, if I wanted to be a bad actor, I'm sorry I'm so evil. But what I would do is come up our system by making these.
Yeah, he's talking about a denial of service attack, right?
Yeah,
Just,
basically.
Right.
But maybe you deal with this in the same way that we deal with other types of denial of service attacks and push the work back on the request.
Well, yeah, well, show up with your plugin and then let's have a conversation. So,
Yeah, I like it.
Yeah.
I think we've reached a pretty good consensus on how I kind of see this working. I got a lot out of this. Did you, Pat?
Yeah, I think so.
I have two meta questions.
Can I?
Okay, I think it will go David, Dan, Remen. Okay.
So one question is like, who's the decider here? What's the
I think-
decision-making context for this? Is it vote at every plumber summit? Is it Ask Bailey? Is it, so that's
No.
one.
The actual, so the decision mechanism is awarding a proposal with a phase one, which goes to a consensus vote.
Of,
The WASI subgroup.
Of the
okay,
subgroup.
I just wanted to make sure that was spelled out somewhere.
Yeah.
So that was one of them, which is you gotta tell people, please bring your denial of service attacks to the following meeting.
Yeah.
And we'll talk about it. And then the other one is there a time-based dimension to this, right? Because we mostly talked about like categorical kinds of considerations for what's the boundary of the WASI quadrant of the galaxy, but we haven't talked about specific
Yeah.
things.
Well,
We don't want you to, nothing having to do with running a nuclear reactor, right? Or, just stuff like that. Are there other and does that change over time? Do we feel like we don't want to like open ourselves up to WASI-fy everything? Does this space grow over time, or is it
targeting
like infinitely large to start with and we'll just figure it out? And I don't know the answer. It's a meta question.
Yeah, I mean, I bet that's basically, I think the previous answer of we figure it out democratically is the answer to that.
Okay.
Like, we're the people involved in WASI today. In a couple years, there might be a pretty different set of people who are actively participating in WASI. That's a much bigger set or something. I don't know. I don't know how that's going to work out. And if we make a rule today, they could just overturn it. So why don't we just kind of make that as late binding as possible, where as each of these proposals come in, we kind of consider it and we make our arguments and then we try to vote and form a consensus.
Right.
Sounds good.
I mean, I think the only thing that's bad about that is the additional work that has to go in on every one of them, but I guess that's not really a problem. So
I
maybe
mean,
it's like,
that could be a problem at some point, but I think for right now, it's, I don't know. I'm really cautious about trying to come up with rules that'll work far into the future. Because I think a lot of rules we came up just a couple years ago have not even served us super well in getting us this far in some cases. So we did our best then, and I don't know. I guess I'm just on the side of less rules, more democracy.
Yeah, I mean,
Andrew, do you know if you beat out Dan and everybody catching me from closing the session, or if you're in queue?
Andrew, go ahead.
Go ahead, Andrew.
I did have one additional category, malicious possible thing to add. I'm interested in this category, the eval like APIs, right? Where you're essentially, like in WASI-NN or WASI-SQL, WASI-GPU, you're passing code across the boundary to be executed on the host side. Think about this case, WASI.js. The WebAssembly program, constructs some JS string and passes a JS string across the boundary to be executed on the host side. That's sort of like the right.
We're able.
It's like the furthest extreme of that sort of line of thinking.
Ben, by the way.
Right.
One of those, not like the other though, in that web GPU is fully spec'd and fully sandboxed in a sense that the other ones are less so. So different dimensions. I think web GPU you can think of as, you're controlling its IO in the outside world. Although of course you can exploit a driver bug, so there's always that dimension of concern. But other than like incorrectness, I think it doesn't somehow violate that way that the eval some JS and eval some SQL.
No, wait. JS also has a spec, and JS also has, if you squint, a sandbox, right? And in a similar sense, you could argue the same for SQL, right? Or
no, definitely not that one. JS is in the in-between area, but SQL does not have a spec. It has a plethora of
it has many variants, it has dialects. But you could say that there's a subset of SQL that there's an implicit
and web GPU. It's in a different category.
Well, actually, I think it would be similar to like Dan's example of file system semantics, right? Where the basics are all there on all the different database vendors, but the actual specifics of, if you really dig into the weeds, yeah, there's like, intense differences. So anyways, not to belabor that point. Hopefully it makes sense where I was going with it.
I think the JavaScript, the question is like, what does it have for an environment? Like, do we have a global objects, like stuff on it you can do, like node APIs, or do you have web APIs, or like what would be the APIs towards the JavaScript? That would be the point where I would really start to worry.
Yeah.
So what do we think about this entire category of, there's a spectrum, right? Of more spec'd out, more sandboxed versus, just run binary code. Yeah. WASI x86, right? You just pass x86 across the boundary, right? Like what are we saying? No eval at all? Or are we saying some eval?
Some well-defined sandboxed eval, okay, on a case by case basis.
David, are you responding to this topic?
Yeah, somewhat. I mean, it's really tough. So with like key value and blob store, which we've considered for adding, none of those have a spec.
But they do have many clear implementations that a lot of people use. And I think that a lot of people have taken stabs at it, a la like Dapper and others.
And say that represents an independent industry collaboration to intersect. Right?
Well, what I'm saying is I'm more drawing the point that the specification is not necessarily a clear indicator that we should implement the specification. We didn't implement a specific file system specification. We implemented an abstraction that fit possibly many specs. So is that more the case?
Seems like what we need to do is outline WASI's goals, right? And make sure that the specs that we're proposing meet the nature of those goals, which I think, with key value, it's clear that we want to enable applications to have portability.
Yes.
And we don't, but I would say that most people generally, when I say key value, you immediately think of a shape of a thing. And for me, that's kind of like, okay, that needs a word, in that it's an industry need that we all have. And so if it's solving real industry needs that have multiple reference implementations and meets the goals of WASI, therefore it works. Now, Dan, you had something for a while, and then Roman.
A lot of what we talked about is sort of structural issues about APIs. I think actually Andrew is kind of the first one kind of delving into the content. So like, what is there a domain or a set of domain restrictions that you can describe for WASI? And I kind of think the answer is no. But I wanted to sort of like put that out there. Do we think that WASI is really this the open scope as far as technology domain.
Is the domain that it must be sandboxable?
I think that's more of a structural thing, like the structure of the feature, but it is kind of that is like getting out of the boundary of what Andrew was as well.
Dan, I like missed some of the words you just said. Can you restate what you just said?
I won't speak on these. So I'm saying like a lot of what we talked about so far has been about like structural questions, about like implications or vendor specificity or IP concerns or whether it's worth it to do a left pad or not. But I'm actually curious to see if there's any disagreement with the idea that WASI doesn't have a technical domain scope of saying, like, is there a subject that would be off limits as opposed to a structural reason to be off limits? So I think sandboxing, like, can be sandboxed, sort of be a structural limitation, like, some things can and can't be sandboxed by their nature, but like we can describe the sandbox. But is there a topic or a domain that would, or a boundary where we can say like some topics are in scope and others aren't? And I think that's the thing where we sort of say like all topics are at least in scope, subject to the structural concern. Is that fair?
WASI IoT refrigerator.
I mean, if it met the other structural requirements, I think that would be in scope.
There are lots of kinds of refrigerators.
Yeah. In scope with the understanding that also involves a language component.
Right, sure.
Yeah, WASI said, WASI again.
Yeah, I mean, and part of the reason I asked because this has historically been an issue in other similar environments, right? It's like real time versus not real time. Like, we struggled for years to not get real time into Java, for example.
Real time, constant time is
even though it was JS implement.
You need to have in those domains, you need to have a combination language and library approach.
Right.
And so that would have to be part of the bigger picture, but like for the WASI side of it, that would be good.
Yeah. I mean, to me, a lot of this is like the S in WASI is system, right? But I mean, what is system actually?
It could also mean standardized.
Or sandboxed.
Want it to be.
Yeah. We actually have talked about the possibility of renaming.
Yeah, well, and then I think to some degree, that's gonna be one of the questions in this larger discussion is gonna have.
I guess I could share Miro.
Yeah, so anyone on the call, does that make sense to say that there is no topic or domain bounds? So it's just structural bounds? Did you want to hear that?
Does that make sense that there are these structural bounds, but no domain bounds? Do you agree with that, Andrew and Pat?
Sure.
Anybody else? All right. I hear you,
Yeah, I mean,
Andrew.
the domain bounds are kind of just established democratically. Like,
yeah,
if the embedded stuff needs to be part of WASI, then embedded people need to show up at WASI. That's kind of the way we've drawn that rule so far, right?
Yep. Yep. So in that case, it's like, are there people willing to do work? Because there's work involved, but not that embedded is or is not a WASI API. Like embedded is in scope. We just need people to do the work and move forward.
I think it's a question of level of abstraction. Like, I don't feel like IoT fridge really belongs in WASI. Well, I2C does, right? So, like, because we wouldn't want to have IoT, food, like, insert anything IoT. Like, we wouldn't want
IoT
that,
or
right?
not.
Yeah. It's like something more generic. Like more generic.
Want to let them know in case they want to be involved.
But I would want to have like, I think it would make sense to have like more generic, like IoT.
My brother works at Fermion.
But the other thing I want to say is about.
He worked there. He worked at Microsoft and DS Labs.
That's some volume. I'll deal with that. Will you guys let them know that Joel's talking? Can you hear Joel, by the way? Online people?
Yeah,
Yes.
I can barely hear what's going on right now because there's lots of cross.
And he mentioned that Fermion was hiring. Yeah, that sounds pretty good. But I didn't really know that much about
I could hear him better than I could hear Dan.
So I had to ramp up pretty fast.
I think domain wise, it would be in scope. I think it would be a lot of work to do it well.
Oh, for sure.
And I don't, the short-term future, see anyone stepping up to do that work. But I think actually long-term, I mean, there's also, have you seen the Wally stuff that seen you? I mean, I think that could also potentially be in scope in the long term. I think it could be a lot, it could be even more work to take that to but I also think in terms of priorities, in terms of like what I and people I talk to would want to prioritize, that's not the top of our list.
Oh, sure, of course.
But it does
It
have a place in like a broader WASI ecosystem as we build out. We start talking about, and people actually talking to the Wally folks, they're actually pretty excited about the idea of re-implementing WASI APIs that are currently host things on top of Wally, right?
Yeah,
And then
yeah, yeah.
on the whole thing, even WASM, isn't that cool? I mean, it might be cool. And I think WASI could be a place where that could happen. I think that's the only limiting factor there. It's not the scope or the topic, but people at work and the prioritization of that work.
Except for fork. It's actually kind of a thing. That's cool.
Well,
Forget
okay, so fork, yeah. Everything else with a star on it except for fork. And maybe single head like, but yeah, anyway.
Well, you gotta have some, well, okay.
David, will you read that?
Something there.
Will you read? And or address, I can't quite read it at the skew.
So we needed to have an answer.
If somebody could say what they think about that out loud. I can only read half of
I
it.
fully agree with Dave. Again, it's like, you need to treat WASI like standard library essentially, right? Then, you don't put everything in standard library, just like a Rust build, right? And so definitely need to know like when to make that distinction in something that essentially the community builds and what or maintains and what we maintain. And probably there will be, maybe WASI embedded organization, or like maybe not really called WASI, but something like that eventually.
I really like that. I think maybe an action item would be to capture something like this as a goal for WASI, so that whenever we're making these decisions, we have a common set of goals that we're trying to decide against. That might really help in some of the trickier situations. But then democracy prevails. I did a sort of switcheroo here. I moved the WASI and WASI SQL topics into this one since we had already started touching it. And it's 2:08, so I'm running like a little bit behind, so I'm eating into the WASI and WASI SQL discussion. And I was wondering if maybe we could dive into that a little bit more, since it's pretty relevant, I think, to what we're talking about here, which is we've got a thing that people are excited about, lots of people want it. But maybe it kind of has that like open socket sort of problem in that is maybe underspecified in a way or difficult to specify in the case of SQL. I know lots of different people in the call have lots of different thoughts on this one. Would anybody like to start? Can I nominate you, Luke?
Sure. About SQL.
Yeah, let's talk about SQL.
Yeah, so a bit of relevant context is web folks tried to do web SQL, 5 or 10 years ago. So like, and their goal was just like, we have SQLite in the browser, let us ship it now. Okay, let's wrap it up in a web API. The challenge, even with that single fixed implementation, was there is no precise spec for SQLite such that web has this very strong concept that we need a spec that's independent of implementation, such that there could be an independent implementation written to the spec and actually work. Even with one fixed goal, which was SQLite, they're like, this is too much to spec. We don't even want to, and so it killed the whole effort. I think what people want from WASI SQL is even more. Like SQLite's just one. I'm gonna run on like 100 different databases, and so just having the generic WASI SQL where it's like I'm gonna throw over a string of SQL and database figure out is just won't really have any portability. It would really just be a socket. Like you might as well just have a socket that talks to this database, and then you're talking over a socket. You can say whatever you want over a socket. Like WASI SQL would not be adding very much more other than a little bit of typiness, I'm gonna like say we type czar for how do I issue a command, and it would really just be a slight typed up socket. If we wanted to make something that actually ensured portability, the only thing that's like seems adjacent and easy and doable, not easy, but doable, is to say, as part of the interface name, we name a precise like popular open source database and its precise version. So we're like, I'm speaking to a database that understands Postgres version this. And that is the subset of, that's the length of SQL I'm speaking. It's whatever's in Postgres, be this. That's a thing that could actually be explicit and portable. And when I get a components, I see what it's importing, WASI SQL, Postgres, well, I know what to give it. I may not have it, but that's what it wants. So I have a chance of being portable, or at least saying no and saying, I'm sorry, I don't have a Postgres. You'll probably break. So, and maybe there are certain strings like ANSI something, and SQL 91, and then ideally, like there's some like
way to validate that you're not stepping outside of that precisely defined language. But that's if you wanted to like be more portable than just Postgres. But anyways, that's a partial thinking of like, what could we actually do to make an actually portable standard?
Oh, maybe it's more questions. So I didn't actually manage to say it last time. So I think what we really nice have the interfaces which are essentially extendable, depending on a vendor, for example, let's say hardware vendor or something, right? If they want to, like ioctl in Linux, right? When you want to have something specific to hardware that you want to expose through otherwise a common interface. I feel like it's a similar case where it's like kind of like in Go standard library. Now you have a SQL Go package exposed, right? And then there are these adapters. These can be provided by external parties or maybe in internal library. So it feels like what I as a developer, for example, would want is to have some similar approach. I don't know if we can do that, but nice could essentially define a shape of something in some kind of shared WASI interface, a WASI package, and then have a way to provide essentially implementations of that trace.
But then you could say, why not just build a component and link it? You know, we've got a whole great system for that. You need WASI in this case. Are you talking about an abstraction that I can program to the abstraction and say, I've told you enough when I name this interface that you can independently come up with a verbal implementation. If what you want is, I want this particular adapter, well, link a component. Yeah.
Like just having basically like Postgres, for example, version, pins, like interface implementations in the host seems like a lot to maintain, right? If you want to support multiple databases, well, you have to maintain a lot of code.
But maybe if you want to run components that these components assume Postgres and these assume MySQL, you may have to have both because they're just totally not interoperable in so many scenarios.
David?
So Roman, your case about the Go API for that. The Go SQL module package has what kind of an interface?
Yeah, it's very small interface. I haven't written Go for 3 years now. I remember, I think there is a concept of transaction, right?
Indeed.
But mostly it's just strings, if I remember correctly.
So you're throwing like basically there's an execute.
Yeah.
So you make a connection. You specify a connection string with like connection due.
I think it's actually encoding, decoding, like basically like serialization helps with that. Like essentially it's just utilities for talking to SQL database. It's not really, doesn't really give you full functionality, right? You have to write a lot of code and you can still like integrate with it. Like if you have the Postgres package, it would essentially reuse parts of SQL. I remember correctly, right? Again.
You're talking about SQLX. Is that the one y'all are talking about, or are you talking about?
It's cross-plate. I'm talking about the Go SQL package.
Well, SQLX has a Go one that I've written a lot too.
Okay.
And what is interesting about it that's relevant here is that you usually also import your driver. So you import like a Postgres driver or a MySQL driver or something, and then that's the part that knows the goodness. And the other things are generally common, right?
What things though? I'm trying to be specific.
Oh.
About. So like execute.
There's query and execute, yeah.
Thank you. Thank you. So there's really two. Oh.
I was just going to say, like, from my experience with that is not to be able to build abstractions on top of, but rather to have a familiar API. But when you're programming against it, you always know that there is a specific driver that you're never writing a generic SQL.
Yeah, so they have abstractions of rows, of connecting to things, open ping, that sort of stuff.
Yes.
For the bigger stuff, you have custom stuff for cursors that's unique to the database that you're interacting with. Yeah, Ryan? Oh, Andrew.
Well, I can't. The conversation has moved on.
Sorry, Andrew.
I'm sorry, man. Hey, will
It's
you
all right.
shout? My back is to the screen. I
Okay,
should
it's okay.
do better, but it like also hurts my neck to look
I'll
up.
bring it up to you, Bailey.
Thank you.
Gotcha.
No, I think you guys got that. Like when we start talking about WASI, I have some comments about WASI that I'm like writing down here.
I just want to Yeah, I just said earlier because it really helps clarify. I think like when you have when you have an interface that you program against in a generic way, where you really don't care about what the specifics are behind the scenes, you just care about the interface, then that's when you bring it, you import the interface and program against it, not knowing what it is. But when you need to care about the specifics, that's when you make it a specific. So I think, you were talking earlier about like the host having to have a whole logic in it, and it's also not necessary. You can build a component that only works by the sockets and then build in Postgres, then a driver against it and the link against that as well. So like not necessarily putting the burden on the host, it's just what is your programming model?
So what's the exact, like, why would you not just do it in your guest code then? Why wouldn't you just use WebSockets directly to connect to something? Like there are tons of libraries already in the ecosystem, right? Rust or Go, whatever. So what do you actually gain by doing so? You have your component there. Let's say that you're, Cloudlang and you don't have a Postgres driver, or let's say you're a new language, or you encounter a bug in the driver and say, oh, okay, I got to work around this. Well, now you have an entire software ecosystem to reach for, and if you want to use your language's library for it, that's fine, but it also restricts you a little bit in that it's baked in, as opposed to saying, well, if I want to switch it out in the future, I have a way of without having.
Maybe you don't entirely trust your like particular library you're using for that.
What do you think we should do, Ryan?
I'm thoroughly on, I don't know what the choices are exactly that you're implying, but I'm thoroughly on the like WASI-SQL, the bad idea, which is like.
Yeah, but people want it. What will be a good option?
Explain to them why it's a bad idea.
Okay.
And give them the path forward for what they need to do.
For WASI, we want to offer SQL-like services to cloud core users. What should we do?
I just don't think that that's possible to do.
I think our best option is, if we want to do this, a thing, is to pick precise open source popular implementations and include them in the name of various interfaces.
Yeah, that's what we do in Spin. We have spin specific SQL, SQL library.
Our previous conversation, maybe that means nuancing our definition of WASI one more time, as we've done iteratively now, which is fine. It's a democratic process.
Could you write a plugin?
Well, I mean, at some point in time, you want to write a component that's going to run a platform that has like brings with it
All the
whole
other
database,
stuff.
the actual database, like running in a whole separate process or cluster of processes, right? So
That's a big step
What's-
up from I got a program that wants to, interact with the database, and the database I have happens to speak SQL.
and you're like, well, what if we say, well, we gave you WASI sockets, isn't that good enough? You can talk to the database, and you're like, well, like, come on, like, what's the IP address? And we have this goal of like, I've got a component and I can, reflect on it to know what it means. So, just saying it imports WASI sockets is a little maybe too raw for certain use cases.
Okay, then maybe we take from the Go playbook and say, we'll just give you the bare minimum so that you have a very old interface that feels familiar. If you'll make a section, for instance, you provide the driver that you're going to use. And it's not going to be the world's most useful thing, but it will be a little bit better than just importing that stuff.
Well, I mean, it might, it might be as low tech as saying like, we're just gonna offer those basic commands, execute and query, but we're gonna include that what you would call the driver just in the interface name. It's like, why is equal single slash express 1.2, it's just in the stream.
Andrew?
Well, Roman, you want to go first? I'll go after you if you want.
Okay, thanks. Yeah, so it feels like maybe what we want is essentially a resource, which is then reused in this, let's say, WASI-SQL could have this resource, which is a connection, for example, or transaction or whatever else, and then actual implementations like WASI Postgres, or maybe possibly that, or just, okay, WebAssembly database, colon, whatever, Postgres, something like that, right? And that would be essentially extending those WASI-SQL objects and then providing that functionality. But there are many databases, and then we wouldn't want to have all these. What about InfluxDB? We have, it's kind of SQL. Yeah.
Is there a concept of like
in WASI just having a package that is interfaces. So like WASI SQL is a set of like a very small set of interfaces. And then you had like slash Postgres slash MySQL slash whatever. Okay.
We do have that. I think we're onto something here.
Yeah, you can have lots of interfaces in a package and only implement a subset. There packages, a collection of interfaces you can choose to.
I should have known this already.
So I don't know if, here's what I was gonna say earlier. I just want to plus one Luke's comment about version vendor pinning. From a WASI-NM perspective, that's exactly what you need to do. Because otherwise you're in a sea of nonsense, essentially. and so, you know, now it doesn't like, you know, the way it currently looks in WASI-NM isn't the way it'll probably end up being, and it doesn't look like additional interfaces in the WIT, because I don't know if that actually maps directly to what we're trying to do, but that discussion is ongoing, right? There are not only different machine learning frameworks out there, machine learning framework versions, but different specifications of IR that they support with, you know, different additions that you can mix and match in all kinds of different ways. And so I just want to say +1 to that idea. Like, I think there needs to be a way for the user to know, oh, these are the kinds of models that I could pass in. But we have not fully figured that out yet. It doesn't seem like an unsolvable problem, though. It seems relatively, you know, it can be done.
So how about a WASI databases with, you know, slash Postgres slash MySQL slash Redis, maybe, I don't know, slash MemCacheDB?
With
We
a
love
read.
SQL for that last one, but not the other ones.
Yeah, well, let's also try not to get sued by Oracle. Let's.
You know, and also like, I kind of got your idea what you're saying earlier, which is there could be an interface that doesn't care about your notation, that defines certain common resource types for cursors, and how do I do a query, just passing a string and getting a cursor and all. That's a single interface, but it ultimately takes a handle. To get the handle, you import an interface that has the precise name in the interface name, and it has a single function, which is like, give me a connection, right? It returns a handle, and now use the common stuff. So there's this common interface, but the way you get the handle that you can use the common stuff is by making a vendor kind of like, that says exactly what you want to open that connection. And then WASI can standardize most. I would think we want to limit ourselves to stuff that's like open source, not vendor specific. But then any vendor who has their own namespace can be like, you know, MS colon. And this is just the opener interface. So the common stuff is shared, but the way to open it, that's when you publish your arbitrary and, you know, company specific namespace, because those are a lot of databases.
So one potential issue with that, though, is that you're feeding data in and data out of that conform to certain data types, and those vary in the database as well. And so like, there's no good way that I can, how to be generic over that.
Well, let's say we said list of U8 every time we did.
Yeah, but then you kind of want, right, to say, well, I don't really want to list of U8. I want to talk in SQL databases. So like, is there some way to go from the list of U8s to SQLite database types in a way that is kind of thematic feels right?
When we kind of forget the query language differences and say, maybe we could come up with a set of, say, WIT types that we could like map to different schema types, then we can start to do stuff. I think that relies on with this WIT templates feature. Until we have WIT templates, I think we have to do kind of fairly generic, like strings and lists of U8s.
And then for instance, like you can just add your own types in.
Yeah, right. WIT can only take us so far.
I mean, it sounds like if we're using our own interfaces, then we should be able to kind of subtype in a way.
Well,
Give a results set which has MySQL rows or Postgres rows.
Right, that.
Well, at that point in time, there's not a shared interface. It's just your own bespoke Postgres interface, which would be fine, right? We have WIT, you can do that. And at that point in time, maybe just, it's not in WASI, it's just in the Postgres namespace owned by the Postgres community.
Composition to create that. Pose the generic component that works and wraps that execute function that does the conversion from the list of UX to
Yeah. That's tricky. Now I'm wondering is like, should we be saying, is WASI the place to put these things, or do we say Postgres community? Why don't you define some width?
Kind of brings me back to my point, like.
Yeah, and
Maybe it's not WAS, maybe the answer to SQL is not WASI SQL, it's Postgres SQL and SQLite SQL.
Which is-
maybe width.
the irony is that was actually our first discussion topic, which is why I decided to speed it up. It felt very, very related and tricky. Joe just said something that that's been my stance for a long time. I'm all about it, but
Yeah.
that's hard.
Substrate's working on this, right?
Yeah, Substrate's working on it. I gave him a big shout
If
2 years
successful,
ago.
we can widify that, right?
Yeah.
Leverage their work, and it'd be like web GPU for databases, if I understand right. It's like, here's a bytecode of relational algebra. That does seem like the holy grail.
Although I haven't really seen it take off, I'll be honest. When I saw it, it was when they had first started and I was like, this is gonna be it. But I'll be honest, it hasn't really happened yet. I get really optimistic about things, so you gotta take that with a grain of salt. I think we need to put a pin in this one, and move on to our next topic, which is host plugins. And then, I think that one will probably go for at least 15 minutes.
Hey,
Then we're talking
before we
WASI
switch,
Yeah.
before we switch, the WASI side of this, we didn't fully plumb the depths of that. I just made a brief comment. I would like to hear what concerns there are in this area for WASI if they're beyond what we're sort of talking here. If you think about it, the discussion we just had about passing around lists of U8s from on the WASI SQL boundary is a discussion we've had in the WASI repository, right? Like, are we just passing around lists of U8s? And I think we kind of concluded no, that then it doesn't make sense to have, the API, I don't know. Then what makes sense is to pass around tensors. And actually, tensors are a foundational resource that all these different frameworks do kind of use, right? And now there may be vendor-specific things that you can do with tensors in one framework and not another, but actually, you can do many of the same things across all the frameworks. And so that would be what WASI covers. Anyways, I can talk about this for quite a while. I'm wondering if there are concerns here, or if we're just going to use WASI SQLs, by analogy, whatever we decide with WASI SQL, we'll decide for WASI.
My first question would be like, I don't know much about WASI or NN in general, but is there a shared common denominator kind of data model for a tensor, like any NN engine, I suppose, would always, like this would always be there. Is there something shared like that?
In terms of the encoding of the tensor, there are variations among the frameworks, but you can declare those variations via different metadata. You could say, these are the dimensions of my tensor, or these are the order of those dimensions within the tensor, or if I'm passing around images, this is the color channel, right? There's ways of configuring that, and different frameworks have different sort of defaults or biases or whatever, but that doesn't seem to be a problem in the spec, right? You could just always say, yeah, you tell us where you're putting the color channel, and that's fine. Yeah.
And I guess we have to ask ourselves,
I think part of this comes back to you don't have generics. So, the way that you'd really want to describe that is it's a tensor of a generic type. And likewise, a row set of generic types, right? We just don't have that. So we end up having to provide that metadata to describe the tensor or row type. And then we have to transfer out of bytes to data structures.
Yeah, it would be nice to have a tensor of F32, tensor of F16 or whatever.
In
Is
case of
there-
WASI-net, you might be able to cheat by just hard coding, because there's probably like only, I assume there's only a couple options here.
Yeah.
F16, F32. Databases, it's much harder because it's any, you want to derive it from schema, which is any row, you want a tuple of whatever's in that row, and that's infinite number of types, so. That's, I think that is a hard problem for SQL that maybe doesn't apply to NF. I think but templates is the generics that we want us to express that, but it's hard.
Yeah, Katie, I don't know if you want to see if anyone else is interested.
I did remember something interesting about OpenGL. In OpenGL, you have all these standardized operations, but the way context is OS specific. Windows use the wiggle functions on Linux uses SDL or something. The way you create the context is very much specific to the platform you're on, but once you've got this handle the context, they specify the rest of it. If we want WASI SQL, that's WASI colon SQL as opposed to just Postgres SQL completely independently defined MySQL. If we wanted to try to factor out this commonality, I think that would be the model is vendor specific open connection, then standardized operations henceforth. And that's like OpenGL at OpenGL. That's a well-trodden path.
Seems reasonable. If you can build an ORM over top of like the generics, ORM is its own kind of, battle, but, that's kind of, it seems to me that would be when you were successful. Like if you could, figure out a way that, all right, I can build an ORM over this and abstract under the underlying data store. Okay, it's pretty good example.
Yes, ORM, if you care about the specific dialect of SQL speaking, you would need to know because crafting is SQL. But it would explicitly state that in the post, the geek database specific import that opens the connection. And that's how it got to state that assumption.
Yeah.
Andrew?
I was just gonna say, I don't want to hold up this discussion any further. I'm not hearing any concerns though about WASI-NN beyond the fact that we need to continue to figure out this version vendor metadata question, right? We need to have a good solution for that. But beyond that, like, I don't hear much, I don't know. I'm not even going to ask the questions, right? Because let me not even cause concern. But I haven't heard much concern beyond. We've talked a lot about WASI SQL, not a lot about WASI-NN. So I don't hear any, oh, go fix this type of concerns.
No, I think it's both in the realm of the design space here is challenging but related. And I kind of see the answer that we do for both of these should also look kind of the same, because I would like for the WASI ecosystem to feel like an ecosystem and not many disparate specs that work in really strange contexts. We should be establishing conventions and patterns that other people can apply going forward. And Andrew, you got the misfortune, I don't know, of being the first. But yeah, I wanted to bring those together. I'll note on the call that the other room has moved on to their fourth topic. So I'm doing a bad job moderating, let's be real. But thank you, everybody that was talking about that one. Let's move on to host plugins is the next one on the list. Yeah, I think everybody generally likes them. I wasn't the one that added this to. I don't. Oh, let's go, Roman. All right. Please.
Okay, cool. No, I think we had some brief discussion, I think, yesterday, Alex and if you would still present the thinking. So I think what would be nice is maybe to talk about some real use cases for these plugins that we actually, what user stories want to enable, what use cases we want to cover. And yes, indeed, it would be nice if Alex was here, but he's busy talking some, so I don't know if he's going to join.
Let me help.
been asked to do async calls or present an async export. And so if you're, and as long as we can do that across a few different languages, and then it will be built compatible with each other using what those, I did have to make a small change.
Okay, well,
And then changes that.
so hi Alex. Hey. Yes, we want to talk about host plugins, right? I want to, I feel like it would be nice to discuss some use cases we want to enable, like what we as organizations have, right? What user stories we care about, right? And so this way maybe like define some like design requirements essentially we would have for this solution, right? Like how it works. So like I don't like at least in our case, like as Monica was about, right? We have this idea of remote capabilities, right? And so for us, in fact, for us, we would need to have like two of these all of these paths that you discussed yesterday, like the dialib and then RPC, right? But potentially RPC could be, you know, a custom thing, let's say we built on top of the dialib, right? But both paths would be very interesting. And so, like, yeah, I mean, let's discuss some use cases that we have for it. Like, that's possibly like what was the what kind of user stories you want to enable? Or,
Well, this, I mean, from Fastly's perspective, I think they were mostly happy just building their own Wasm time and like having like custom crates in that regard. So I'm not sure if Fastly has a whole lot.
Okay.
In terms of Fermion, I mean, but so I'm, at least for me personally, I've been sort of vicariously bringing this in just in terms of, I mean, regardless of that, I think the main value is not so much the use cases, but rather what you enable. So this is primarily you can have this plugin which is not tied to a Wasm time version. Having those versions separately and having distributed by different means, I think is really important. And I think very useful property to have, just so you can like upgrade these things independently. You don't have to have them tightly and all that. So that alone, at least for me, is reason enough to pursue this sort of thing, which is just getting it so you can provide post functionality that does not use the Wasm time crate directly.
okay, so for example, WASI would WASI itself be a plugin? Like,
It could be, whether it is or not, we can always debate that or like figure out afterwards, but I think I would like to enable that because I would like, I mean, I'm always a fan of making Wasm time nice and tiny so we can move it if we can. But, so I think that would be a good tool to have, whether or not we actually do that, I think depends on the particulars of the solution, which figure out over time.
Is there a goal of being able to build a crate that could either be statically linked or dynamically linked via plugin, but it's the same crate that, you know, implements certain same kind of public interface, it's kind of how you build it that turns it statically linked.
I suspect we should not take a goal of like all of the use cases have to be exactly the same. In my mind, if they're all roughly the same, like they're all like something generates a trait, if you want a trait, it does the thing. But what exactly, I think it's best to leave it up to details. So like, for example, if you're statically linking Rust, you're almost certainly, like, in that case, it's a little less clear of like, can you tie to Wasm time? What's the benefit of divorcing yourself from Wasm time? Like, but at the same time, whatever API we do have for loading these sorts of things, I do think one in the Wasm time crate. So we'll have an interface in the Wasm time crate saying include this plugin. So if you had a static link plugin that was written against Wasm time, you don't use it. If you do have it using whatever dynamic or static thing, you might not literally use symbols, you use like traits or Rust functions to hook it up, things like that. But that's legit. That's my rough thinking. But I don't know. I mean, I haven't planned all this out too much because that's very much in the dialog case as opposed to like the C stuff. And did you talk about the component, like using the component to your so much?
We have not talked about it.
Oh, okay. So one for the thing, so Brian was talking to me yesterday, mentioning that instead of having like, one thing I was saying was that we would build RPCs on top of dialoops, but that's actually maybe not the best idea because RPCs you can do all that once. So Ryan had a really good idea, which was instead of doing that, you could imagine a system where it's like given any sort of WIT interface, you can generate a component which exports that interface, which then translate it to some sort of RPC. And so you can, in theory, do like dash whatever RPC protocol you want. So you can take anything and you can, particulars we can still quite figure out, but it's like the idea is that's all component based. So we don't have to worry about any of that. So all you have to do there is that like getting it into an RPC don't help. It's not too bad. That's just like the stuff there. We can enable everything, component generator stuff else together. And then so it may not end up being that the
the RPC case is built on top of dilibs. That actually, those are separate. Or dilib is more like fasting the lowest overhead we can possibly think of, but the RPC is more like you can just tack on a component to go out, and then we do want to develop host generators for like in the RPC, like we can still like generate Python interface or Rust trait things to put it into. So it's like the rough thinking there. That doesn't necessarily directly apply to some of these questions.
So if one wanted to contribute to this process, to working on this effort, so how would one do that?
So it seems like there's probably a couple of parallel things here. They're actually pretty, I was hoping that like they would be pretty related, the dilibs and RPC stuff. It seems like that may not end up actually being the case. So in that sense, these might just be totally independent projects that are all under similar-ish umbrellas. So in my mind, kind of the base of all this is like you've got a bunch of WIT generators generating in Python and Rust and all that. So like that'll be shared. So if you want to write a plugin, if you want to write just component host functionality in Python, everyone's going to do that the same way, except for some boilerplate at the end. So that's like shared. But otherwise, whether or not we're going out via RPC, whether or not we're going out dilib style stuff, that's I think a little so parallelism here is like dilib might be entirely separate from RPCs. RPCs might mostly look like developing a system to generate a component which would translate all calls into RPC calls. And then so that's like one part of that system, and the next part of the system is like receiving those RPCs and then dispatching it to some sort of language local solution. So that would leave a lot of flexibility up to embedders. It's also, I mean, basically we wouldn't be prescribing too much, but the theory would be like, you would figure out how to spin up a Rust process that's receiving RPCs. You would figure out as an embedder, like this component that like sends out RPCs will have some sort of magical function, which is like, give me the RPC connection. So you as an embedder, we would have to design that. What does it mean to give RPC connection? What does the embedder?
That's one option, but also if the RPC protocol use is protobufs, then the generator could generate a proto file that then you could use feed into existing proto buff machinery, so you could just implement this RPC server as just a completely, there's nothing good about it, it's just proto buff.
And that I think would work really well, but we would still have to generate, the component would have to translate all that into protobuf calls going out.
That's right.
So you need like a protobuf plan, I guess, in that regard. But we would also, from an embedding perspective, you would still have to define functionality of like, okay, that class wants to send this proto somewhere else, a protobuf message, so you have to like, someone has to say, I've connected to the protobuf something, or the protobuf protocol like has these WIT inputs, like whatever, basically what I'm saying is like, whatever the outgoing RPC thing needs, we like, it's just, that's what happens. It may just be TCP sockets, which is super easy. So in that sense, like that might be probably one of the most separable ones and easiest ones to contribute to, in the sense of it's relatively isolated and will require a lot of guts and time. I'm happy to take on the dilib stuff. That's going to take some time just in terms of design and what exactly APIs are. So, are you interested in any particular like concrete, like do you protobufs or anything like you mentioned NATs before? I don't actually know what that is, but
As a matter of fact, we use this for communication. Like it could be, but yeah, indeed, like the RPC case is the one we currently are the most interested in, right? And so I'm working with RPC is framework and a bit based on it. So it would be really nice, like for us at least, about the morning, right, to standardize on that, right? To have or at least partially standardize that approach, right? That would also give us it just build a better ecosystem, right, off of these host plugins, right? Because maybe if we all use the same common interface, well, we can benefit from, a Redis plugin, right, and all kind of things. So yeah, I would absolutely be interested in contributing to particularly like RPC parts of this.
do you have constraints or particulars about exactly how the RPC is done? Like, does the RPC have to have a particular format or anything like that?
No.
Okay.
So in fact, we talked a little about defining like value encoding or like binary value encoding for component model, right? So say if you have a default value, you want to encode that in the binary WASM for that format. So that's actually, well, I already have some ideas about it, so we're going to adapt it better for like existing, consistency with, how everything done is for WASM and component model. So like ideally, that could be like at least a format that we all could use for the serialization of data. Want to, send something from WASM time to a thing. Right?
So I bring this up in the
sort of where I do think this is actually something fast would be interested in as well. Mostly from a like our perspective, or I guess from my perspective, say like we have this issue, like everything that goes in has to go through a very small set of people at the moment. We could actually set this up as see like that would alleviate a lot of that like problem. Right. And for what it's worth, we would probably want something like that as a drawing.
Okay, so that's what I want to actually focus on is the particulars of like a concrete encoding, because you're mentioning like wave style stuff, and I don't like. There's a lot of possibilities we could do here. Like you could imagine you would generate a component which communicates via an RPC, and you could just have a dash object or message pack or wave or whatever. I don't think we should do everything to begin with. I think we should pick ones that a lot of us will probably use and then go concrete. So that's
the standard ones.
Yeah, that
Actually seems like a smart way because then the other side we can use all the existing.
that's what I think is really valuable. And because that would scope this project to primarily generating a component which then exports an interface and then imports the ability to send out RPCs. That you get like all the host language generation already done. You just go. So that's where I might not recommend the wave encode style encoding or like kind of a shared style encoding just yet, mostly because it will require a lot of custom generation for the host side of things. Like we need to take Bitcoin gen, the WASM time, like also put it in this and deserialize it and source the RPCs all that. But if we use part of message pack, if we've already got Rust stuff or Java stuff or Python stuff, that might work out pretty well.
And you don't want to call.
So I'm not really sure I follow the fact. So if you want to serialize a with interface, right, you would need to you would have to use with binding to generate a struct, say a Rust struct. And how do you actually get a protocol coding for that?
And that's what I'm thinking of. It's this component that like exports the interface that you're remoting. So you have like some WIT interface is going to turn into RPC somewhere else. So you're implementing on some. So you're going to generate a component that exports that interface, receives all that stuff, and then internally translates that to protocol somehow. So it's like you call functions, you just call some protocol function, you pass a record and it translates it to it like a protocol struct. Resources, I don't really know about that's kind of function.
But you would need to have a way to translate from WIT to protocol. You would need to have WIT files, protocol files. Yeah.
So if that's not possible, that's a whole new can of worms. Like or it necessarily it's should be possible.
Okay. Yeah, it should be possible. Yeah, but I mean,
Candles will be the fun one. You know, we have to come up with the protocol,
but even that,
come up with things.
Exactly.
Yeah.
And like, because the same way the component model has like bracket names and functions and things, we can just define a convention to say this is how it all goes into protocol. So the theory though is that like most of this project would be building that component and then that's it. And the idea is that like this tool takes in a WIT and spits out a component.
And a message pack file and a protocol file or whatever
Oh,
the
yeah.
declaration that the
Yes.
other side uses to find it. So it spits out those two things.
Very good point. And so then with those two things, with the component, you would then, as a host, like put that into components. So it's like if anything you're running imports Redis, then you would give them the Redis component, like at deploy time, bundle that together, and then you ship that. And then that RPC is going up. And then for the actual implementation, you would use the message pack file, the proto file that pops out, and you would do it. Like those things.
right. So again, what is the concern? Sorry, for using, say, a standard like a component model value encoding? Why would we not want that?
It's not that we don't want it, it's that we may want to do that second as opposed to first. And the main reason is that we reduce the amount of work necessary to get this working. So if we did a custom component model value encoding, we then need to make the host side, which is actually implementing the RPC. Something is going to have to receive the RPC, deserialize all that, have custom traits and all that business. The theory is that message pack has already done all that, or protocol has already done all that.
Right, but so the thing is that with since we have the WIT, right, the actual let's say the server, right, serving this thing, it actually has the WIT as well. It has access to the same WIT. So make this assumption that actually is a very simple task to just go like you give it here these exports or these exports. Right, and so actually defining how to encode and decode the value using that is a really simple task.
I mean, in some sense, if you want to do this, I think go ahead and do it.
I've already done it.
So like in that regard, I'm not going to say this is like this is I think is something we want to have. which is that it's just do something, just make it work. I don't want to deal with protobuf message pack or whatever.
Yeah.
I think there's a lot of use cases for also doing protobuf message pack, but even, I mean, if you're the one working on this, then I would say take whatever works for you and pioneer that, because this is basically the foundation for what other stuff we do. But as the exact particular protobuf versus custom component stuff, I don't think that's too much.
Okay, so do we want to set up kind of like working group or like, I don't know, so a group of people working on this, or like how it's gonna process?
It would probably be good to start a repo. I don't know what repo. I don't want to have. Do you think this would fit anywhere? Is there an existing tool this would fit into? Because I don't want to make a new tool.
I think it's a new tool. I think it's gonna grow. I think it'll be a collecting point, like it'll get the proto first, and then it'll grow more. So it'll have some shared ecosystem.
It's almost entirely separate, like a standalone tool, this component generator, except the thing you mentioned earlier, where WASM time needs to provide a little bit of connection setup. Machinery, like how do I pass this command line arguments or config file to WASM time to say, hey, connect to these other daemons, processes, whatever. That's the one little bit that probably has to touch WASM.
And that's where, like, I imagine that logic is still going to have to be like per WASM time version. Like every time you update WASM time, you're going to have to update this logic. But the theory is that like this is very small and we don't break it very often, so you should actually never have to update it in practice. Whereas with WASI, it's like it's so big, it's very unlikely we tweak one little thing here and there.
You can find like an interface for this, say like, the way this works, you can socket handle. The sockets.
No, exactly.
And you can pass that as an argument, and then there's no setup, at least on the component, generated component side, there's no setup. And all the setup would be on the last time. So it's like, I know if you give me a component that has this shape, that speaks, some arbitrary implementation coming in, socket going out, I'll give it a socket, and I know how to instantiate that on it.
I wonder if this would be interesting to have like a WASI plugin package or something like that. I don't really know if this would work, but the idea is that like you could have an interface for custom component stuff. You could have an interface for protobuf, an interface for message pack. They all seem like they're probably going to be slightly different. Like one just wants a TCP socket, one wants to go to like make new TCP sockets.
Really, it just wants an output stream.
Right? Yeah, exactly. Yeah, so something like that. So that's where I like. What I would imagine is that we would have an interface. It's like per kind of protocol that you're using. And then we'd have documentation in each protocol saying,
Yeah.
this is how it's used.
So that way, this repo wouldn't have any WASM time bits in it. It would just be like, all I do is you give me a tool, CLI tool, you give me a WIT, and also I'll create, you use as a library. You give me a WIT, I give you here's the component, and then here's whatever interface that goes with it.
Yeah.
And there'll be no WASM time bits in there at all.
Yep.
Does that make sense?
Yeah, absolutely. Yeah, that's fine.
And honestly, if the one thing that'd be nice if we standardize like the plugin style interface, so like these things import like a custom output stream or whatever, it would be great to have. We could bake it into WASM time. Like we could have like built-in builders into WASM time, which make it like one-liners to say like I've got a message pack plugin sitting in. I've got things like that. Like we could easily maintain that in the WASM.
So just one thing here is the transport layer that I want to talk briefly about. So like, do we make any assumptions about that? Because like, for example, the approach I'm taking right now is that, let's say I have I assume there is a head specified something. That's how I concept that. So like, message pack if you want, or JSON or other encoding. So it's reasonable for us to then assume like both these restrictions on like the transport layer for the plugin system.
I mean, output format would be selected as you tell the tool generate a component that's going to do message. And it would just do that. It wouldn't have any options in it. It wouldn't have any headers or metadata. All it does is you give it an open stream and it implements a WIT on the other side and it translates that interface into that stream. Or if it's bidirectional, there's the para streams. But yeah.
And like, but I do think this is, yeah, I mean, I would agree with that. And like in the limit, you could imagine that you don't actually have anything here. It's just HTTP. Like it just makes HTTP requests.
Wait, so HTTP is already a lot actually. Right?
But I mean, like at the host layer. So like you would assume the host can do HTTP. And so that way, in the sense that it's like I'm saying this more so as like, the idea is that like if it's low level, then it's already baked into WASM time. So WASM time can already do TCP sockets. WASM time can already do internet connections and all that. So if the transport layer to get to the other RPC side is just HTTP, you don't actually need anything custom. You might need some stuff around setup and like permissions and things like that, but nothing too fancy.
Right.
In the case for like a streaming message service or something like that, So let's imagine that host plugin gets fired up, it starts, it connects to, you know, MQP or, you know, QTT or something like that. And it gets a message, and that message needs to get passed back to Plasma Time to send it to make the guest. Are we thinking about this as a bi-directional?
I've actually.
First, I think you have some, so this gets, we're gonna invoke the tool, we're gonna tell it, are you talking to a one directional stream or a pair of streams, you know? Or are you talking to quasi, and they can just HTTP requests, right? Or are you receiving requests? Which one do you want? And then as a developer, you define one that's gonna match what you want.
What? Wait, hang on, but you're talking about like triggers. This is like you invoke new WASM as a result of like some message going in. Is that what you're talking about?
Yeah, I think go either way. I mean, you can have like a request comes in, I turn that into a call to what kind of import it. We're talking about like I get a call to one of my exports and request going out. Both generations, like obviously it takes work to implement both of these things, but like I think both are useful.
That I have thought a lot less about. I've mostly been thinking about more so you import stuff and you turn that into RPCs. Having like external events trigger calls into WASM totally makes sense. But I have just thought, I don't know. I've given that way less thought.
So in that case, the socket accept loop is going to be in this generated wrapper. And then it's going to parse the low level thing, which is incoming sockets, going to parse whatever, craft whatever things, and then call into the guest component through its exports. Is
that like, what did it even look, because that, I'm not sure would you want that? Because then it would involve like, you're saying you would wrap the component, which has like a handle function into like a CLI application, which has a single run function.
That's one option.
So how it works like right now in the POC, I have both exports and imports, right? So we polyfill them, right? And so basically, like we use a message queue where essentially for each export, you listen on a topic. And if you get the message on a topic, you just invoke that function, right? Like you use all this introspection thing and all that. Feels like it should be possible to wrap that part of logic component. I mean, you would need.
So what does it look like to run a component in a system? Like, do you
said what might be overly simplistic? You would need runtime instantiation if you want to create fresh instances.
Yeah. So like
without that, you might need to be more bespoke.
Do you run a new instance on every message, or do you have like one instance that receives messages over time?
I think it's a new instance in every topic. Yeah, we instantiate every time we get because apparently instantiation is cheap, and that's actually if you want to do for security. So
that's fine. That is.
It gets very tricky when, let's say, a guest returns a resource and then needs to keep the resource handle around for a while. So then, I mean, or if you return a resource, then you want to call a method on a thing. It gets a bit tricky with the run trips.
Because like with the import happen things, what we were mostly trying to think of was can WASM time implement like an absolute bare bones, like everyone wants this kind of thing, and then you give a component that translates your custom stuff to RPCs going out, and the RPCs are implemented in terms of bare bones, HTTP, TCP, all that. If we invert this to think about exports as well, we want WASM time as little as possible as but the bare minimum. But it doesn't really have. Like right now, we need to identify that. What does it mean to have this bare minimum? And maybe it's.
Let me revise what I said last time. Let's say the accept loop of raw sockets is in WASM time, but as soon as it accepts a new socket, then it spins up an instance with the guest that's wrapped as a parameter. The socket it just accepted said do something. That probably addresses the last problem.
We're at 3 o'clock, so we gotta move on to the next topic. Yeah, we have time at 4 o'clock. We're gonna be running a project organization session. We can probably have, more breakout rooms. We've got big room and a big hallway. So I think, if we've got stuff that we can solve in person together faster synchronously, let's do it. But I want to take advantage of, oh no. Yash, you were just here. You were just here and you've been replaced by a cat.
Turned into a cat and ran away.
How did that happen?
He's a witch.
Dang. Okay, well, so our next topic is gonna be on fuzzy HTTP tools. And what's your cat's name, Yash?
Hey, that was Naughty Cat, who apparently was very hungry, and I only like realized it like as you were saying, "Hey, it's 3 o'clock." I was like, "Oh my God, I need to feed the cat." So I was like, she's very cuddly. I don't know.
Okay,
So
well, I would like to know what WASI HTTP tools are.
yeah, absolutely. Can everyone hear me okay?
You sound great.
Yes, fantastic. Yes, hey everyone. So I'm Yash. I work at Micro. Yeah, I've met many of y'all. Met many more I may not have met, but I'm Yash. I work at Microsoft as a developer advocate for cloud native. I've been doing around like WASI things for since before WASI existed, sort of like loosely, but I'm kind of went away. Now I'm kind of back again. Anyway, yeah. So WASI HTTP Tools is a little initiative that I did not conceive of, but Luke had a good idea that I was like, hey, we should build that. And so I started building it a little bit. And I realized, like, wait, hold on, Luke will probably have talked to like a bunch more other people. Sorry, I'm putting you a little bit on the spot there, Luke. I'm sorry about that. It was like, wait, hold on, before I like build out the entire thing, let me like, have a moment, sit down with people, talk about it, figure out where are we at, like what should we do? Is this the right idea? Did I understand it right? And then see where we want to take it. So hence this little session here. So what we have so far is we have two things. And I will attempt to screen share. I hope I have permissions for it, which I do not. Did I?
To screen share?
Oh, sorry. Hang on.
Thank you.
Okay, you're good.
Yeah, fantastic. Thank you. So I will share my screen real quick, which is here. Sharing. So we have two things right now. One is a repo with a skeleton of a project. It doesn't do too much yet, but it contains three-ish little sub projects, which I'll explain in a bit. Some like testing things, etc. That is one thing. I'll say more about that. The second one is a type system definition. So the idea of WASI HTTP tools is to essentially ask the question, what happens if we have components that don't just live on one machine, but we have components which exist on separate machines that we would like to connect over the network, right? So WASI assumes that everything's local, everything connects to each other. In fact, with Docker, we have things local and we connect them over the network. And we're saying like, hey, what if we didn't have the network, which is great. But, the distributed system, distributed things, like things live remotely. And so sort of the first click stop here is to, we want to be able to connect components to project network things into WASI. And one of the things we probably want to do, or like not probably, like I know we want to do because we have people on our side who are like super interested in this. They want to be able to use their, WASI runtime. They have existing backend APIs, and they're saying, hey, I would like to expose my backend APIs into this runtime. So, people can build their little WASI programs, load them in there, and then make calls down. And in order to do that, we need to oh, the little macOS like thumbs up. I don't know why it does that. But in order to do that, we need to like provide projections for that automatic, or not even like automatically, but I want it to be automatic into WASI runtime. So essentially, the way it works is we take an open API definition, which is the standard sort of like HTTP endpoint definition thing, and then we project it to WIT. And so I defined a little type system for that, which is here. Dan looked it over and thought it looked okay. That's as much as I've like seen for it. So that's one thing. We've got a type system for defining how do we take open API definitions, schema definitions, and project them like back to WIT. And we think we can do that. Now there, actually, let me stop right there. Does that make sense so far?
Yes, and I love it.
Okay, great. Okay. That's good. Yeah, if you're interested, the repo's up here. The little link I'm showing is like here on the right-hand side. You can click through. I attempted to explain like what, for example, choices we've made around the password type, what that means and why it has a meaning and like why we're not doing anything with it. But that's for y'all to read at some point perhaps. So the roadmap here that I view is gradual, right? So the assumption here is, or the thing here is, we say, hey, we have WASI, we have HTTP, we would like to connect different WASI things over HTTP. We would like, for all these things to make sense. The first one is, so first click slot. I'm not sure if I'm using that word correctly, but for this I made like little pretend these are slides. So take an open API definition and map it to the WIT type system. We have the physical mapping or the on paper mapping we have done. Now make this automated. So take an open API definition, automatically generate all of the right like WIT files for it. So that's the first milestone. That should be pretty doable. I just didn't write the code, but I know how to do it. The second one is take an open API definition and generate a WASM component SDK. Probably targeting Rust, but the point of this is that we can like generate a concrete component from this that we could then load in. And if we had a registry, we could like publish all of them or some of them, or, however we'd like to do this. Just being like, okay, great. Here are all the SDKs. A way that we can do it is I've got a little submodule here checked into the repo called Open API Directory, which is an open source like collection of open API definitions that are gathered. This gets updated. It says 2 weeks ago. Oh yeah, because it's the exact like version. But this gets updated every single day. So in theory, we could automatically generate SDKs for every service under the sun and like check it in the way like TypeSpec is checked in on NPM for TypeScript. Something like that. But that requires taking these open API definitions and generating components from them. A thing we can do. A thing, I think is sort of the second point here. Then the third one, and this one gets a little bit more interesting, is reverse mapping. So we take a WIT definition, and can we create open API from that? Can we say, okay, here's your WIT, and now we will want to expose this over HTTP. So like a server scenario, this will have very interesting questions about like, how do you take, a data type and what is the right projection to do that over the network? This will have, I'm not 100% convinced that this is like for everyone or for everything, just like ORMs are kind of like, this gets very ORM-y a little bit, but it could be extremely powerful. Right. And then the final one is like, take that idea and like turn it up to 100, which is what if you have WASI data types and you say, if I take this as an import, like automatically, like here we get the network layer. If I take this as an export, here's the server layer, and you connect the two. Things of caution there is we can't just, like a function is not just a function. A function is probably asynchronous. It is probably fallible because the second you hang it over the network, we don't want remote objects that just, randomly like hang if we like try and access them. So we need to do our due diligence, probably generate like additional layers around it. Dan like sat down, made a little sketch of like, okay, I think we can like probably expose it like this. And then I lost the link, so I can't show you what the exact WIT mappings could look like. But it seems like there might be a way of doing it where we do like service those values, preserve the properties, that we show, hey, this thing is actually networked. And these network calls can actually fail. And then I believe this was Luke's idea. What is really cool of that is if you then say like, okay, I'm going to point fingers here. I'm very sorry. If you say you take like something that looks like, hey, I'm a network like servicey thing here, or a server here, I'm a network client here. We're going to, have a system that has knowledge of both. And then they end up being deployed on the same like node, like next to each other. Then what you can do is in the projection of the two, you don't need to run it over the network anymore. You can just be like, okay, well, your signature says you're fallible and asynchronous, but under the hood, really, we know this is a direct, like, system call, and it will never fail. This failure path will never be taken. So an optimization path from that. But yeah, that's super far out. I believe the sort of like roadmap here is start with open API to WIT and then start from OpenAPI to generate an SDK, and then we can start doing all the sorts of reverses there. Okay, that is sort of the idea roadmap in a at the high level. I haven't written the code for this quite yet. I do know sort of how I'd want to approach it, but I wanted to open this up to the room. Like, what do people think? Do people have thoughts on this? Do they have opinions? Is there prior art? Are people working on this already that I'm not aware of? Also, how would we operate this? It currently lives under my GitHub project name. I would like it to not live there because I think this is much bigger than just me. I think this is probably relevant for most people doing things with WASI on the network, which is most of WASI. So yeah, let me leave it there. Let me open it up.
I have lots of things to say. This is awesome. One, thank you. There is some other art that I think makes sense to join forces on. And I love the last part here, number 4. Yeah, I think the whole ecosystem would benefit from collaborating around it. And it's something that I think could power a lot of the internet. So I'd love to get it in something like the Bytecode Alliance with open governance, or CNCF, or wherever. I think there's a lot of places that it could fit in. But definitely the Bytecode Alliance as well. And Roman, I think I know what you're gonna say.
Yeah, I will say, but so also we talked about this new repo. So it seems like if we were not to limit this to HTTP, we could have WASM API tools, perhaps something like that, but also the plugin thing fit in nicely. And yeah, so it's just as an example, we at WASM Cloud are working on an RPC framework. We've actually it's not specific to HTTP. That's the only thing, but that 4th point, exactly what we're doing right now today. So yeah, I guess we expect in the month to see if we have some we could contribute, we could work this together, collaborate, maybe build something really interesting here. Yeah.
That's cool.
A lot of different points in the design space here. It's really hard to see where they can unify. Because WIT to OpenAPI, OpenAPI to WIT to BC protocols, including OpenAPI, but other things. Do they all unify in one or two all or are there separations in the space?
We also have a case where we need WIT to Smithy, Smithy to WIT. And I imagine that the code that I would write to build both of these is the same in a lot of ways. So at least for those 4, they feel similar.
WASM API tools.
Yeah.
So
what is Smithy?
Smithy is the IDL that Amazon uses for basically all their services. It's also meant to be polyglot and all that kind of good. I'm most familiar with OpenAPI, if I'm being totally honest, though, because I used to be on the team of Center of Excellence for APIs at my old company, and having OpenAPI to WIT and back again is going to open up the door to so many developers. So I'm pumped. You can't see me on camera because I'm hiding, I guess, but super excited about this. I've actually also already explored your repo and sent it around to my team and stuff a week ago, but so the excitement is still genuine though.
Yeah, I mean, the idea of the basically
Yeah.
registry with 2,000 components stuck with every open API service.
I only caught half of that. Sorry.
You didn't miss anything.
We're excited.
Yeah, just excitement.
Okay.
So this
maybe. Please.
I just want to see if I can find what's the steps forward here. What's the next step?
So basically, summarize all
The next.
RC.
Do we think WASM API tools is a concrete enough vision to say that's the path forward? Does that name invoke something in your head that you think I can see what that looks like?
Are you guys okay with that? Is it too generic?
Yash, what are you thinking? Would you think about this morphing into something that's much bigger that does what you're doing also much more?
So I have opinions on this. The choice to scope this just to HTTP is somewhat deliberate. I think things like Smithy which, if I'm understanding it right, is also HTTP based. It is just not open API definitions. It is, Smithy definitions. It. So did I get that right?
You did. Well done.
Okay. Great. Yeah. So what I would like to see is like for every transport, like define their own set of network tools. For example, what's the protobuf transport layer, the Google's one, gRPC.
gRPC.
Yes. Like the way I see this sort of like playing out is maybe it doesn't matter. Maybe we can just like open it up and like put all of them like together and like we just like segment them by like thing. But I intentionally like at least my vision was to just scope this to HTTP. But I guess what we're asking is like, does it matter if we name the project something more broad than that? And like, yeah, sure, we could do that if we envision that same repo to also absorb things like gRPC, to also absorb things like other protocols as well. Like, yeah, for sure. But potentially that could also be like its own thing where we say like, okay, here's where the gRPC like tools go. I don't have a strong opinion, I guess.
I think we start with, are you okay with the repo name Wasm API tools, or do you want to keep it with HTTP in the name? We can still reject people for joining us.
I have a slight preference toward HTTP because it makes it clear, right?
Okay.
Like people looking for this, they will understand it is towards like just about HTTP, but it's only slight. If people are like, no, we would like to also extend this to like protobuf, then yeah, sure, let's call it API tools. Or something similar. We can workshop the name basically.
Like potentially I could be sending protocols of HTTP.
Let's say gRPC is just over HTTP.
Yeah.
Oh yeah, fair. You're not wrong.
Look, the question is like scope, like are you okay with this repo growing more than open API stuff?
Are you good with this project having more than open API stuff?
Okay, so okay, let me be super clear here. I want this thing to exist more than I want this thing to exist as something that I work on, that I build. So if people are like, hey, we're stoked for like, let's build everything, let's build all the APIs. Yeah, let's just go with that name. Because like, if y'all like want to contribute that, let me please not hold you back, and we should just build it. That's sort of like why I'm here, not to show off the cool work that I've done, but to sort of like try and give shape towards work I think we should be doing. And yeah, if we think that, let's scope it to gRPC as well, then yeah, sure, let's call it API tools, and let's just run with that. So happy to.
To me, it really feels like it's more like Wasm open API tools. So Wasm API tools feels like more generic how you define an API. Yeah, I definitely have stronger preference for Wasm API tools.
Would you be comfortable going into a repo like this? I don't know if you've seen it, and adding gRPC or protobuf or whatever, generalizing that. Do you think that would make sense, or would you think more in terms of like we gotta start from scratch to have a more general architecture?
Yeah, I haven't seen the repos, so
Okay, that might be a thing we could do offline here, but that might be the question to ask. Is like, is this a good starting point, or like, how do we get to that more general place?
And Yash, is the MIT license, is that just a template that you had used, or is there?
Actually, MIT.
Yep, but is it okay with you if I changed it to Apache 2 with the LLVM exception? If we were to donate it to the Bytecode Alliance, you were to upstream donate.
Oh, I mean, whatever standard for the Bytecode Alliance is
Okay.
good by me.
It
I just
makes
use
it
whatever standard
easier.
for Rust. So yeah, absolutely.
Yeah, we're actually triple licensed under.
Oh, are we? We're double licensed so far.
But yeah, I'm worth this out.
Okay.
Sure, yeah.
Yeah, so I think
next steps are, I can jump in here, that Roman and anyone else interested in looking at implementation here, take a look at this repo, see if it looks like something we should say, like this is the starting point, follow from here, or say, no, it's not the starting point, but maybe it's a useful thing to have we'll make a new repo, start a new architecture. So that's the first question, was like, which of those two do we do? Does that make sense?
Sure, yeah, absolutely.
Okay.
That's great.
And then either way, then the destination is repo in Bytecode Alliance called WASM API tools. And then that sort of serves as like, it's your gateway from WIT to all the things.
Once we decide that, put in an issue on Bytecode Alliance governance, get you a repo created.
Okay, I can do that. That sounds very practical. Okay, cool. That
Thank you.
feels like we have a concrete next step. Thank you.
All right, yeah, thank you, Yash.
Oh, I'll stop screen sharing.
So our next thing is WASI release train cadence, but we are getting close to being out of time. We have 8 minutes. I don't think we can come up with our train cadence discussion in 8 minutes. So I propose that we break and either join what they also appear to be done. But he says thanks. So I think basically almost all done. So there's hummus and snackos over in the right-hand side, and then probably regroup at 3:45 after, significant break. And you do want to keep talking, I'm not going to stop you. Sound good? Cool. All right. Thanks, everybody. We will come back in with more scheduled programming at 3:45. Also, I'd like to institute a pop quiz, get back, summarize what we learned to the group, because not everybody got to hear it. The first one was, how do we bound WASI? Dan, can I ask you to help? Okay. For WASI SQL, WASI and N, Luke, you knew it. And then host plugins, Alex or Bremen, did you guys learn something cool? All I'm gonna ask is like 2 minutes, not a lot, just summarize what we came to and things that happened.
What time you would delivery of this piece?
3:45, are you prepared? Should be off the top of your head.
No, that's fine.
Okay.
I'll be back.
That's right. Okay, I can make sure that you go first, 3:45, okay. And then WASI HTTP tools, Yash, if you're here at 3:45, I'll ask you to do it, but if you're not here, I'll tap Dan, so no pressure if you have work stuff or something. And WASI release train cadence, I'm just gonna say we're not gonna do it right now, but maybe as part of our project management session at 4.
Yeah, actually, Roman, would you be interested in rephrasing that as the WASM API tools summary?
Yeah.
Instead of the API summary, the things that we generalize the scope of it.
Yeah.
Okay, cool.
I mean, that kind of seems like it kind of involves also the post plugin part.
Yeah. It's not very, very simple. We're like very much aligned. Do we still do the same things here?
Yeah. Cool.
Then I'm doing for both.
Yeah, I think it's like, I have trouble because like there's so many different things we want to connect stuff. Like we want to have all things connect all the things, really, right? And that just feels like a lot of things.
That's a good summary.
But that's where I like the idea of starting with just concrete things. Like, I mean, personally, I like the idea of being a one repo. And if you want to do component model, like custom encoding, and Josh wants to do open API stuff, if both of those work really well and we retroactively figure out how to put them in one tool, it feels like a good situation to be in. But having one repo is like a nice discoverable place with like a shared set of tests. Maybe not literally shared, but like you can draw inspiration pretty easily. At least that seems reasonable to me.
I want to like a whiteboard for this, but like there's like source of truth. It's either a WIT file or it's some other IDL, API, whatever else. So one of those two, we generate the ones in the first one, and then like, okay, my output is either going to be HTTP, WASI or Airbnb streams or a single stream, depending on what kind of protocol it is.
And you can say it going both ways. Source of truth is either WIT or it's part of both.
Yeah, so like all those things have all arrows.
Yeah. And I also want to compose it, like you want to go.
The interesting thing though, is if you go from width to OpenAI to width, you intentionally don't get the same way you started with because you added fallibility. If you're saying it's generated.
Yeah, that was actually.
OpenAI should reflect the fallibility if you're going over HTTP, right? So it actually is, going this width to OpenAI to width gives you the fallibility needed, which is good. Like, yeah, it's not supposed to be a round trip.
Yeah, that's actually, that's when I kind of sketched that out, but yeah, in the results of things.
Yeah.
But I think that.
And also async this, you had to do it like a PV2, but we had to do the manual async thing. This one looked like a PV3, it's like back to original code with async.
Yeah, but I like this idea of, I don't know, if we can centralize around the idea that we're building like adapter components that are like shoved onto, it's like your true component will import some sort of WIT interface, and that's how you do components and things like that. You start from API, you generate WIT, and then work against that, and then you can like adapt that with the whatever adapter that you actually need.
Do you publish the whiteboard?
Is there a reference?
That feels like a solid story, at least.
I can imagine there could be some shared backend sort of tooling that helps you code gen wrapper component efficiently, stuff that doesn't really care what the API was. It's just like, hey, I'm helping you assemble a wrapper component.
Right. The world's my oyster. Here you go. We're calling this thing.
We are hot, by the way. I don't think we're muted, just FYI.
Oh, okay, well.
Not that it's a bad thing.
I didn't say bad thing.
Yeah, just saying for awareness, because we're typically.
We're all the foul language comes out.
So that'd be pretty quick.
Do you really think that's well?
I'm thinking of
Oh, yeah, burgers. Or have sticky notes.
Oh, sweet, thank you so much. All right. So. Yeah. Bit. And then we have over here, there's like a whole bunch of things. There's like.
Yeah, open API, we got Protobuf, we got.
There's Smithy.
Smithy.
There's. Yeah, is there like a Protobuf schema thing?
Protocol buffers. Oh, I thought it was Protobuf, yeah.
Okay, I guess it's like Protobufs are the schema, yeah.
protocol buffers, yeah.
We got thrift, we got message pack.
Yeah, and then a lot of things. There's soap. I mean, David. And so we sort of have bidirectional between these two things, right? Because if you want to take one of those things, get WIT. You want to take WIT, get one of those things, right? And we also have
So that's what I figured each of these are. It's like, that's what I was actually a little confused about, like the term WASI HTTP tools, because what you were saying makes sense. It sounded more like open API tools. So this, I don't know. I mean, but if like all of these probably could be communicated over HTTP.
Yeah.
So in that sense, it also works out just fine. But I do suspect that like the selection of the transport layer is going to have very big ramifications of what you actually can do with it. So like if Protobuf has a stream type,
There is, yeah.
we need to get that into WIT streams, but actually WASI streams. So get like, we don't have any constructors for a WASI stream. So it means that if Protobuf has a stream, have to take a like HTTP, like if it's over HTTP, the HTTP has to be like a stream, but you can then return a other component, which actually is back the HTTP stream and everything. But my point being that like, I feel like the transport layer matters a little bit, but I also, it mostly matters from the perspective of like, we want, for each of the arrows, sort of, we want like the ability to produce a component which exports the WIT interface and imports something. And exactly what that imports is like a transport layer in a sense.
Yeah, I think there's layers to this. I don't know about this yet. Like, you can get a socket. So okay, I'm talking to a socket, and then what's the protocol on top of that? Right there. So, or like it's HTTP. Now am I doing gRPC on top of HTTP, or am I doing something else? So like
Actually, what is gRPC on top of HTTP? Like I know, like HTTP makes sense, but
gRPC is like it's based on HTTP2. It's based on protobufs. Also, it's like its own. Like, streams are actually not part of the bus themselves. Streams are actually a thing that get added by gRPC. Because protobufs are just a serialization format, there's nothing else, there's no RPC partner. You need to have the stream to get back to actually RPC.
Did you define services protocols? Yeah, you define services in protocol buffers, which then in their signature, the functions they have streams. Right?
Define services in gRPC.
In the protocol buffer.
Protobuf is the encoding format, right? But I was under the impression that protobufs are just a serialization format.
Dan, that's the difference between protobuf 2 and 3. Protobuf 3 added the ability to define here's a service, here's an endpoint as well.
Protobuf 3, okay, this is a new thing that since I last looked at protobufs.
Yeah.
But then, so like, does WASI HTTP have all the things necessary to do gRPC?
I don't think it has all the HTTP stuff, yes, but I think.
So it depends also, so like in this RPC protocol I use, right? So for streaming and future, so I treat them special, like input stream, output stream, and future trailers, not HTTP. I treat them special in a special case. I don't know if you want to do that in a general purpose tooling or not. That would be a decision to make, but I mean, I do feel like we do need to do something. Yeah, it's not as simple.
I think you definitely special case input stream, output stream. There's part of WASI IO, which we can think of WASI IO as kind of being part of the protocol itself.
Yeah.
It's like a polyfilter we want to add. So input stream, output stream handles. What handles.
I'm also saying this from the perspective that mapping arbitrary width into protobuf is probably going to be a bad idea. So you can probably have streams in more places in width than you can have more places. But going the other direction, going protobuf 2 width, like special chasing the streams of protobuf will probably work out just fine.
I think it'll be a fallible transformation. I think you can say like, yeah, you might have tags that I can't support, like handles might just be like, I can't support this for some versions.
I feel like we got to support it.
Well, in some form we will, but like there'll be different questions like what can we do, what makes sense to do, and then it's going to depend on factors. That's why I'm worried about this design. Like, is there a coherent design here, or is it just turned out to be like, let's glue all the things to all things, and then we have to realize like, oh, what is it going to do with handle? It will depend on the context.
Because well, that's where I was hoping that we could say like I doubt any of these have a native thing that's the exact same thing as a WIT resource. So I would hope that we could say that. I don't know, but that's also where I was hoping to scope it, just imports, but if we also want to do exports and triggers and things like that.
I think they're part of the story. We don't need to engineer that right now.
Yeah, we can start with imports. So that's important.
Okay, so but then in that sense, if you're importing a resource, it's always a resource defined by someone else. And so we could say that for every single protocol, a resource is a 32-bit integer. So you give us the integer, and we're going to get back to you. So you, like, the remote service is expected to be maintained. Yeah. And then we also have some way to desugar saying a method name has this name of the remote service and things like that. So that actually would perfectly map an important resource onto your system. The main trickiness is when they're returning a thing which is defined in WASI-IO. So like if they're returning a stream, we want to WASI stream. If they're returning a stream from like some other interface, like that gets kind of funky where you're trying to get that stuff together, but we can, I think.
I actually think it's straightforward. There's a C list going both ways. You have a C list for me, I have a C list for you. So you can pass me handles like RSC handles. And
No, we actually talked about this a lot with Roman as well, which is like if you wanted like if you
something like you call something that something gives you a poll, right? So you want to get a push from the server. You don't want to be asking, "Hey, are you ready? Hey, are you ready?"
I think poll goes in the category of things we use in special case.
Yeah, no, but I like pollable is not even possible because so we're imagining this from the abstraction layer. Have a component which is like you call it a component, which is then doing component stuff. There's no way to construct a poll. Like you can't just create a poll out of nothing. You can create a poll stream, but like it's a stream thing. So we can't say that like some arbitrary service can return a random poll for random things. We have no way of constructing that.
It's important. It's important pollable. It's still a poll. Like you could you call something as something, calls another something, right? Then you get the input stream. Then you get a pollable for that input stream and you.
So that's possible, yes. As long as we can map the streams going correctly, because it's like like the component, when it does its outgoing stuff, it's doing HTTP things. So anything derived from that can create HTTP stuff and it works perfectly. So we just map that out. But if there's if a remote interface is a function that's like, given my handle, I return a global, we can't do that. So we have no, unless we like map that to some weird.
Yeah, not literally, but there maybe we could like explain that intense.
But I'm hoping we don't have to do that. Like, I'm hoping that that's like, I don't know if Protobuf has the ability to express this, like in Protobuf, because Protobuf probably doesn't have the concept. Like Protobuf probably has streams, but streams can map very easily to HTTP streams and output bodies and all that stuff. And you can get foldables for those, that's all good.
So they don't really have streams like the same way as streams in Web. Stream essentially is the property on a parameter vector, parameter tuple, whatever, or result tuple of a function. So you can so you always have, okay, there's no tuple, there's always one message, and then you can have a stream of message. You can get back a stream of message, or you can send a stream of message. But it's not a structured thing. You cannot have a message which contains a stream. That you wouldn't be able to do.
But it is structured in the sense of it's type stream. It's not always a stream of bytes.
It's always type stream. It's always a stream of some message that is like, you cannot have a stream of bytes actually. It's not us.
Actually trickier because if you want to model a incoming stream, you call a method and it gives you a stream of strings. Protobuf has some way of encoding all that. We can read the byte stream, we can actually get all that, but the host component, like the component which is calling this, has no way to get a pollable for the next string.
I think we could look at this in the context of API. I'd like to defer run engineer this particular problem. And like when we have a use case, like sit down, someone says, I have a gRPC service or whatever I have that has this API and it's got a stream in it. What do we want to do? And like just approach it from that kind of perspective. Then we can talk about like, is there a place for pollables? A lot of all the things that the service is doing in terms of pollables and hand out to the side or whatever. I think that'll be a lot easier to think about in the context of a particular problem to solve than like generalize from there. I'm having a hard time thinking about it because it feels like there's so many different kinds of use cases you're going to have. How do you want to do it? Are there many streams coming in? You want to like select over them or like pull over them or whatever? Or do you have like care about the latency coming in of the events coming in on these streams? Is it events or is it like a data stream coming in?
So these intricacies, I also said that it feels like components native value encoding is actually easier than converting for plugins, right? To convert stuff to Protobuf, refer to Protobuf, and then use that. It's actually pretty difficult, and there are many things you can find conventions. Like how do you actually like send a string? Because you cannot just have a string of string. You cannot do that. You actually, I don't think you can even send a string. You have to always send a message that contains a string. So you always send structs essentially, which have numbers. Otherwise, you get this backwards compatibility and all that. And so, yeah, it's not direct. It's not direct mapping.
So message is just data serial. Data serialization. There's no handle stream stuff that on this. So that'd be a good example for like. So we would talk to our OpenStream or OpenStream. It's like you're just serializing to the streams. It's not HTTP.
But is message pack not the bird over here?
I mean, it could be.
I mean, I guess I don't know. I'm the wrong person to talk about all this because I don't know the intricacies of any of this.
I mean, you can funnel up for anything or anything else.
Yeah, but like I mean, I
serialize data how you want, and you can get by over serial or whatever.
But if yeah, it's. I mean, I guess what I'm sort of concluding is that, at least from my perspective, again, I'm trying to hope that we have like a small set of primitives that we can assume in WASM, which are very easy to implement. It's very easy for us to provide you a crate, like look it up or whatever. So like we can give you like connect this to that HTTP. We can give you like one liner which is like connect this function to that HTTP.
That HTTP, right? Like we say, there's two, maybe three that I care about, or maybe four in the directionality. They're like there's HTTP and there's streams, and we talk about incoming, outgoing for both cases.
But this design decision provides a pretty limiting view on what the actual plugin can do. So for example, you can't put arbitrary streams on polls and everything all over the place. Like you can't import a bunch of resources. Like I can't make an I can't make a function call which takes an HTTP body as a parameter.
Why not?
Because that would involve like forwarding polls, forwarding information, like
They take the HTTP body, I put it in a table in myself, and I give you an index as a C list. And now you can pass it back to me. And say,
No. It's more, it's the derived functionality from that, which is like, this is kind of what I was talking about too, at some point, like with Pollable, it needs to figure out how to implement itself with remote stuff. But we don't have any interfaces for that, right? We're not defining how to create a pollable message. So I'm trying to think about some of the context of but it's probably easier to think of it like they return to me an HTTP body. But if you try and do that over an output stream, like if your transport is a TCP socket, I cannot create a WASI HTTP body from a TCP socket in the component. Does that make sense?
Can you hear me over there?
Yes. Yeah. What's up?
One of the motivating things that I found useful to help clarify, I'm in favor of C ABI for plugins, and one of the clarifying motivations for me was WASI Crypto, where you really care about performance and you really don't want to copy a bunch of times.
Oh yeah, and to be clear, I'm thinking of this in terms of I think the answer is we're gonna do both. We're gonna do CABI stuff and we're probably going to do RPC stuff. But my hope is that we can, like, we've sort of since evolved that RPC stuff is primarily component adapter style things, not like the WASI adapter, but like full components and composition. And so they're basically just gonna be totally separate things. And the CABI stuff is going to be pretty complicated, but we'll just, yeah. So everything we're talking about here is definitely not that, not CABI, then none of that. So I don't think anyone's gonna want to put WASI crypto on the server. I think this is more so like the Open API or the RPC, or like I've already got some service defined in something. That makes sense.
Yeah, thanks. I came in late, so I didn't catch that.
So we talk about HTTP, like we don't need that for plugins, for us, in our context. I actually also have the special case WASI HTTP. And the reason for that actually is because if I want to use wasn't-time WASI HTTP implementation, well, I cannot actually use the WASI HTTP quit because the structure is different. I would have to re-implement my own WASI HTTP, right? Because for all the resources, but not in wasn't-time, I get an actual HTTP request, and there's an actual future stream, or maybe just a device stream, all that, right? And so like these, like I have found so far, most recent thing is actually special case all the well-known interface.
But that's one.
I mean, it's tricky. It's not.
That's where every component is some it brings it home as this context function of that's a lot of this is why it's exciting. Just because so for example, and she was like looking for menus one day, found these like right, and it just lists out every source that it uses in there. It's thousands. Oh, sweet. They do like the restarting the probably using 12% maybe, but it's open. It's a platform that is want to lay on you, so we're like. I guess. That'd be fun. The way to tap into the cute pedal and
Actually, it's good. So, yeah, it's a good break session. Possibility of. Yeah, that's right. They're not going away, they're not going. Right? It just shows like. It's not slow. Investigating here.
Okay, let's get back to it. Happy to have you.
Just to get our control.
That's okay. I
Hello, hello. We are back on stream. Although I know that we kind of technically have sort of always been here. We don't have video. I'm putting it on video. Hello. Can you see me okay? I have an echo, so I'm gonna walk down there and fix the echo.
It says no video for you. Like it literally says no video in text, which I've never seen before.
Yeah, we have a fairly crazy setup here, so give us just 1 second.
Neat. I see. How about now?
Yep, we're good.
And I'll put on a video for so that you can get from here. That really good. Okay. Back. So the first thing I want to do is just have a quick roundup of what all we talked through, because most folks probably were in and out on each session, maybe didn't catch all the context, even in the sessions that they were in. So if we could summarize anything we learned, key takeaways, action items, that would be really helpful. I'm gonna do this by writing down the list, I think, and ask folks who helped either put on the sticky or know that they're supposed to be speaking here to give us a little summary. So up first is documentation. Kate?
Hi, everyone. So within the documentation breakout, we started off by naming the areas within the Bytecode Alliance where we feel like there is documentation, and then we dug into each and talked about gaps. So the main areas were WAS and time docs, component docs, so that's the component model book, WASI docs, which is less consistent, but we have WASI.dev, and then we have all of the interfaces. And then talking a little bit about how we would like to have WIT interfaces have documentation tied directly with them through the AtBox proposal, and some tooling that can show it in a more human readable format, kind of like a REST doc setup. And then we talked about, despite the Alliance projects in general, moving towards better documentation and putting effort in there as we can now that we've stabilized a lot of that tooling. And ideally, one specific thing was trying to link to the component book instead of the spec. That's becoming a more readable format of that. So those were the main categories. Digging more into some of them. One call out was that we have WASM.io coming up and KubeCon, and so trying to get all of our documentation flushed out as much as we can before that is a major call to action. And with that being said, trying to get SIG-Docs going and set up some meetings more regularly so we can keep each other accountable. If anyone wants to add more updates on that, feel free to chime in.
That was great. Gonna bounce to Joel, right here.
Yep. Hi. So yeah, shared everything linking. This is just one of my pet projects, that came out of the Python componentization work. And it has a couple of benefits. One is it works really well with native language integration in Python, Java's JNI, DLL import in C#, Ruby, native extensions, that sort of thing. So that's one reason you might want to use it. Another reason is to reuse runtimes so that you can build components that actually import the runtime and standard library rather than duplicate it. And that's especially important when composing high-level components built from high-level languages. And so it was mainly just me evangelizing that and answering some questions about that. And then in terms of action items, I'm going to try to work with the JavaScript, .NET, and Ruby folks on implementing that for their various componentization tools. So if moving on, if we want to move on to WASI TLS, yeah, we talked a bit about that. This is a new idea. We reflected, Dave and I and others have reflected on the WASI sockets design and implementation and realized that most real world use of sockets involves TLS, database drivers and so on. Not so much an issue with WASI HTTP because of course, it's sort of abstracted away. But if you want to connect to say a Postgres database or a Mongo database, you're going to want to do it with encryption and maybe even control things like certificate management and that sort of thing. So we want to have some way to do that. Compiling, say, OpenSSL to native code is not necessarily a great answer because of the lack of constant time operations, although there's been renewed interest in constant time ops, so we'll keep an eye on that. In terms of action items, we'd like to maybe propose WASI TLS as a real thing in an upcoming WASI meeting, and maybe create a repo on the WebAssembly GitHub org to start sketching interfaces for it. So that's where we're at with that. Moving on to async. We talked, I sort of did a little bit more in-depth Q&A about this ISIS WASFA thing that I created. So that was mostly what we talked about. We talked in particular about how to minimize the pain of, going, if we ask or if we invite people to use this sort of preview of Preview 3, what happens when we actually deliver Preview 3? Like, where do we leave programs that were using this sort of like hacky version of Preview 3? And some of the ideas surfaced was, well, if we get the binding generator right, recompiling from source should require minimal changes. And Lan even suggested that we could potentially create a binary adapter from this hacky version of Preview 3 to the real version. I'll have to ponder that. And another question that came up is how do we, if these start showing up in the wild, given that the world that you're targeting using ISIS WASFA is not actually the world that you get because it actually transforms, it splits functions up into two functions. Is there a way we want to label these somehow? Is this something we want to, publish to registries? Big open questions. And then overall action items, at least for, in this experimental stage, we can just do whatever we want and, treat it as a prototype. And so from that perspective, we can enumerate the languages we want to support, things like Python and JavaScript and so on. Maybe implement async to sync composition, get some real world exposure to that since that's the more interesting case. And then, from a standardization perspective, write down the spec that Luke presented earlier, start discussing it on GitHub and other arenas, and start implementing it, potentially in parallel with, the polyfill that ISIS WASFA provides. That's all I got.
Oh, that was a lot. That's awesome. Jumping over to Nick. What did we learn in WASM time debug session?
I think we just mostly went over stuff that is kind of floating around in SIG debugging and my head, and that I need to make an RFC. I don't know if we really learned anything particularly new. But it's not new for me.
What's going to be in the RFC?
Approach to how to do debugging, how to do stepping.
And this is all inside WASM time?
Yeah.
All right, thank you. How do we bound WASI? Pat, actually not Pat. Dan. Sorry, I know you're eating.
All right, so we talked about WASI and so bound WASI means there's a way we can say what's should be WASI API, what should not be WASI API. We talked about a number of what I like to call structural considerations. Like we like to have APIs that have multiple implementations, although that might not be an absolute requirement, but we like to have that. We like to have implementations that are, or APIs that are not tied to a particular vendor, APIs that are not having intellectual property constraints, APIs that must be fully sandboxed, are kind of something we talked about. And I think we agreed also that beyond these sort of structural concerns, there is really no topic constraint. There's no domain constraint. Pretty much any topic or domain people would want to do could be in scope for WASI as long as it's kind of met these other structural concerns. Talk about. Another thing that came up that was really important is that we also like to see in general a lot more community exploration. We don't necessarily need to have APIs start in WASI, which we sort of had done in the past, that we can do a lot more things where community people just like build stuff, and then whatever becomes popular, those people realizing. Kind of a subtlety about like picking winners. I think standards bodies are all about picking winners, but we don't want to sort of preemptively pick a winner. We want to make sure that winners kind of emerge organically.
One quick kind of comment on that to make it very explicit, including for people who might be listening in on the live stream or watching the recording later. This is not some kind of official opinion of WASI as a standards body, because we are not in a WASI meeting, and we're in a Bytecode Alliance context, and this is kind of to some degree a consensus on this topic that is emerging in the Bytecode Alliance, and to some degree opinion of individual people who are both active in the Bytecode Alliance and in the WASI standardization context. But it is, no matter what anybody sees as a consensus here, has no bearing on what WASI as a standardization body would say or hold. There's no decision being made here on any of this.
Yes, that's a very good point. Thank you, Jill. I can also add to that like some of these ideas are things that we might propose to WASI as like, these are things, because I think WASI subgroup has a need to communicate what it intends to do. And so we might take some of these ideas and feed them up if they would take the formal proposal and they would be voted on by the full subgroup. So yes, what we're talking about here is just like Alliance folks. And there's nothing really even official here. Like we didn't vote or anything like that. It's just like what we talked about.
Sounds good.
So that's all I have for WASI. Did I miss anything?
I think you covered it. I think the one other thing actually is that we really like APIs that potentially already have a spec, because they're already used in some other contexts and somewhat of a standard way.
Yeah, if it's existing API, that's a strong signal that this is a thing that can be standardized effectively. And it's also a good place to start from in terms of writing a spec. It's not strictly required, but having an existing spec in a domain is a strong signal for a good candidate for a WASI API.
Okay. Then we talked about some of these other APIs that are, let's say, a little bit harder to bound. Where's Luke? No, Luke? Okay. I'll summarize this one. We pointed out, and we spent a lot of time talking about WASI SQL, and mainly what we were discussing there is that the lingua franca is not actually SQL. It is whatever it is, the driver that you're actually trying to talk to. And that's kind of hard. But we came up with some kind of interesting ideas for how we could maybe have some type of connection, and then having interfaces that are specific to the database that you're talking to. But maybe have a common interface, like maybe starting with like a resource type, and then be able to pass other pieces in. And in a lot of ways, it's similar to WASI in that way. Andrew, if you're still here, do you mind summarizing the aspect that we got to with WASI?
Yeah, I think one of the things we were discussing was this vendor and version specificity that you need to be able to sort of declare which version and vendor of a model you're using, kind of like you would in SQL. And I had mentioned that WASI in those working groups that we've been having, we've been discussing those things. Was that mostly it?
Yep, that sounds good. Moving on to our discussion on host plugins.
Yeah, so the consensus is that we want to have both models. We want to have DOI libs and RPC-based approach. And it seems like the RPC-based approach would be like the simplest and the quickest way forward. What we want to do there is to have essentially an adapter component, which is not unlike quasi preview one adapter, is an actual real component, which would essentially expose the plugin in terms of some common API, which is maybe just a stream. Just a stream. We are going to have at least one repository, which is going to define the RPC stuff and generate and some tooling to generate such an adapter to then provide the APIs. Yeah, we have quite a lot of interest in this topic, and yeah, we're going to have to accept the fact that we're going to have some limited support, most probably of full width interfaces in preview 2, because of limitations of until we have preview 3, you're probably gonna have to just accept. You're not be able to do anything we otherwise want to do, particularly in terms of streams and like async and things like that. But yeah, go on the repo stuff. I think Dan will tell us more about the next topic. So there's quite some overlap with API tooling to discuss.
Yeah. So we talked a bit about Yash built a repository and kind of sketched up a direction for something called WASI HTTP tools, which focuses primarily on open API and bridging from WIT APIs to open APIs and vice versa. And it's totally cool. And then I think we talked about like that looks cool, although we're also talking about a number of other things that are kind of in that same space, but going to different directions with like instead of open API, there's also like Smithy, there's also protobufs, there's a bunch of other serialization API, RPC, IDL, schema things out there. And so interesting question, like, do all these things become their own project, like GitHub repository and their own different people working on them, or should we try to unify those things? It seems like the rough consensus that came out was that it'd be really cool if we could unify these things. And there are probably also a lot of parts that they could share. And so next steps is people are going to take a look at OpenAPI or at the WASI HTTP tools repo and see if that looks like a good starting point for generalizing into WASI API tools repo, which would sort of be like I take WIT or I take some other definition of an API and go to it, and then I can generate a component that adapts that API to arbitrary things that eventually talk to input stream, output stream serialization, or HTTP requests.
And we actually did not do this one because we ran out of time. And that is our wrap up. So we're at 4:08 now, and we planned for about 20 minutes for talking through WAC, because that's something that's come up, throughout basically the summit. And I'm really bad at multitasking, so this is me sharing and giving share permissions to
Before I
people.
start, what time is dinner?
Oh, yeah. Let's do dinner at 6:30. Was that about right for most folks? This walk is a little bit longer from here, but if we leave at 6:30, it's still walking distance, and we're heading to Transfer Food Hall. Yeah.
Awesome. Okay, looks like we can all see that. My name is Peter. For those of you that don't know me, I work on a bunch of different WebAssembly related things, and one of them is WebAssembly compositions, what we're calling WAC, just as a silly acronym, but also as the name of the language backing this tool. So before I get started, I just want to give a little bit of a backstory. I originally created WAS and Compose to demonstrate the potential of the component model. As we transitioned away from module linking and interface type proposals to an actual component model proposal, I had originally authored this tool called WAS and Link, and that no longer worked when component model became a thing. So we needed a tool to show really the potential of linking different components together and their composability. And so that's where WAS and Compose came in. And for the longest time, Luke had been showing slides of the component model illustrating a formal linking language or an example of linking language. And I didn't want to be the one to implement that language with WAS and Compose. So I initially punted on the idea of designing a language and settled on everyone's favorite configuration language, YAML, which is a horrible way of representing a DAG. And it's very confusing and it's not very easy to understand or use. So Brian came to me from Fermyon and said, hey, why don't we start replacing YAML with actual language that is a little bit easier to understand? And then a bunch of other people, Luke, Trevor, and others. And we sort of started noodling on what a real language would look like for composing components together. And so that's where WebAssembly compositions come in. It's effectively just a textual representation of a WebAssembly component. And internally, that component is linking other components together. That's all a composition is. Because we want to represent types from the component model, it made sense to base this off of WIT. So it follows the WIT. It's a proper superset of WIT. So everything you can do in WIT, you can do in WAC. But WAC extends that to let you import stuff, export stuff, and instantiate and link things together. So it has 3 additional statements: import statements, let statements, and export statements. And I'm going to go briefly over the syntax for each, and then we'll go into a demonstration. So import statements, they're just binding a local name that you use within the language to an imported item. The types of those items may be expressed as a package path or inline. And optionally, you can give those import statements an as clause to give it an explicit import name. The tool uses a lot of inference for naming things for imports and exports, because I don't know if you noticed, but actual names in components can be quite long and verbose for like WASI and things like that. So it's trying to make it a little bit easier on the developer that's defining a composition to use shorter names where possible, or no names at all. So some examples we have at the very top, incoming handler, which is the local name, and that's going to be an instance of WASI HTTP incoming handler 020. And that's from a package path. So we're actually importing it with that package path just automatically. Next example would be giving a local name F to an import of foo. So we're actually providing the actual name in the resulting composition as foo. And here it's a function of that particular signature. And then finally, an example of import I. And since we didn't give it a name, it's just going to be default to I because it's not specified by path. And we're saying this is going to be an instance of this interface here. So all of that type representation is directly coming from WIT syntax, and it's just subsuming. So next we come to let statements. These bind a local name to result in an expression. WAC is currently a very simple language, only supports 5 expressions, but that's going to be updated very soon to really complex and really cool things. But for now, we just have local names, which is results to the value of that name. Instantiation expressions, which I'll go into detail in just a second. Postfix access expressions. So we have a dot notation where you can access the exports of an instance using a dot format, or you can give it a bracket syntax and a string, and that string is always going to be what we're looking for as an export of that instance, where the dotted notation will do a little bit of inference to figure out dot streams might be WASI-IO streams and not just a streams export. And the most exciting of all, of course, is the parenthesized expression, which is just wrapping any other expression in parentheses. So instantiation example. Here we're binding the name foobar that we can use later on in the file for various things to a new instance of component foobar. And we're referencing this foobar component by a package identifier. And that's going to come into play later on when I show the registry integration of how useful that is. So we're instantiating foobar, but we can pass it different syntaxes. Is that a word? It is now. For giving it its instantiation arguments. So there's a few different forms, and all of them are pretty useful. We have the short form, which I mentioned, streams, or on the left-hand side might be WASI-IO streams, depending on if there's only one import that it's taking that ends in streams, we will say that that is going to be the name that we bind this argument to. Similarly, we can give it the exact argument name, and that's just a string, but those get verbose, like I said. So we try and avoid them where possible. On the right-hand side, you'll see that we support expressions in this position. So we're giving this argument the export foo of instance I automatically for you here. Next is the inferred argument name, and that's you're just passing a local name, and it depends totally on how that local name was bound to things as the instantiation argument to try. So if X here was an export of another instance of a particular name, it will try to reuse that name when importing it here to this instantiation. We have the ability to spread exports from an instance. So this ... I syntax basically says any of the exports of this I instance, basically spread them out and pass them as imports to this instantiation. So this is useful for cases where you have like a virtualized WASI component that's exporting a bunch of WASI interfaces. I don't have to link them all up here. I can just say, take this instance, whatever it exports, import it from this instantiation. So that's kind of sort of the novel syntax there. And finally, we have implicit imports, which says this ... at the very last position, anything that I didn't specify or was otherwise unsatisfied as an argument will be implicitly imported from the composition and passed here. So this is very useful for where you have lots of different components that use a whole bunch of WASI interfaces, for example, and you just want to import WASI from the outside of the component and pass the WASI implementation down into all the components you're instantiating internally. You do this with the syntax, and the tool just automatically handles importing that, merging the definitions together, and passing them down for every instantiation. Okay, so that's instantiation. Next, we have export statements, and these are sort of the inverse of import statements. They export a local item from the composition, and you can also have an as clause in these to give it explicit names. So some quick examples. If you export foo, this is a local name, we infer the export name depending on the context of which you bound foo. So if you imported it with a particular name and you're exporting it again, for example, it reuses that name. The as clause there gives it that explicit name saying, no, really, I want to export this with the name bar. Or like we have instantiation spread syntax, we have one for exports as well. So this is basically saying, I have this instance foo, whatever it exports, just export this from the composition itself. So if it exports CLI run, we can just get CLI run output from the component that we're generating from the composition. And I'll show that exactly that in just a second. And lastly, this also supports expressions in this position. So if you're accessing the streams export of this foo instance, and it happens to bind to WASI IO streams, that is actually going to be the export name, and you don't have to specify these long strings everywhere. So that is export statements. I want to talk very quickly about a very powerful expression that is about to come online for WAC as a tool that's going to transform this from not just a composition tool, but also for a virtualization tool and potentially maybe even a distributed component model system tool, and that is transform expressions. And Brian's currently working on the implementation for this, but the idea is basically we have syntax around taking a component, running it through a transformer, and out pops another component. And this is what WASI vert is. If you think about it, you give it a component, it outputs a component that virtualizes some of the use of WASI in the context of that component, and then you can use that component and it has less WASI dependencies. And WASI virtualization is a perfect example of this. These will be implemented also as WebAssembly components. So where you see syntax using these expressions, what the WAC compiler does, basically go to a registry, says, give me this transformer, it downloads it, and then executes it with WASM time, gives it everything it needs, the configuration, the component to transform, and out pops another component. And then WAC then uses that component later on in its instantiations internally. So this really becomes a powerful primitive to extend WAC to do things that we haven't dreamed of yet. So and the internal syntax will use wave to represent these configuration values that we get passed down into the transformers. So just a small syntax for this, we are transforming this foobar component using the WASI vert transformer, and we're going to download that from the registry and execute it with WASM time. And since it's all WebAssembly, we don't care about any of the security properties here. We'll limit what it can do. And what foobar, the hyphen foobar name, will bind to is actually a component. And then we can use that component down in any instantiation expression. Instead of a package, we're just saying instantiate this particular component. And then that instance we can export it or compose it with other things as well. So think of in the future, not just WASI vert, but maybe I want to transform this component. And instead of giving me this actual component, give me a proxy representation of this thing so that when I call into it, it promotes any of that to another place. So we were just talking about how we can potentially leverage that for plugin system. That transform operation where you take a component, give another component that maybe proxies things to a remote, could also be implemented with this kind of model. So it's kind of a powerful thing. And the syntax around this is in flux. We love feedback on making this more usable and understandable to users. 3 people in a room designing language is not always the best way of doing it. So I invite everyone to come in and give what they think would be the best syntax around making this thing work. Yep.
Is there an example what that would look like for showing off the remote?
No, I just meant conceptually, instead of that WASI vert there, we would say, remote or some package name, meaning to give me, here's some configuration of what transport I want to use, what protocol I want to use, like message pack or protobuf or whatever. As configuration to this transform operation, we would download that transformer, pass it that configuration, pass it the original component, and that tool, which doesn't exist yet, would give back bytes for another component. And so when you link against that, when you call the functions on it, it might take as input, the transport to use from the outside world, right? It would then pass and proxy, marshal all the call data to the remote, get back the response, and then return it to the caller, and the caller wouldn't know that this thing had been remoted. That's just an example. I can't really it would be the syntax, but the configuration value would be different. And the package you're using to transform with would be different.
And you said are you having actual meetings on this now? Last time I talked to you several months ago.
Yes. We have a weekly, and it's a I can send you the invite. We have one weekly. So yeah, there's this is all relatively new and not yet implemented within WAC, but it's coming very, very soon. Okay, so I will mention that WAC is registry first. It's hidden behind a registry compile time feature. But when you build this feature enabled, any package references it encounters within a WAC will be automatically fetched and downloaded from a org registry. And very soon that will be based off of the work that Land's doing to transparently make that talk to either org or OCI, so you can fetch these packages from both locations. Okay, so it's demonstration time, and this is something that I was just made aware of I'm going to do as part of this presentation yesterday. So I'm recycling a demo that I gave to the SIG registries group. So for some of you, this might not be the most cutting edge demonstration, but hopefully there will be some value for folks that haven't seen it yet. So hopefully everybody can see VS Code. The gist of this demonstration is I'm going to take this world and implement it in 5 different source languages. And the world effectively imports a function that returns a string, and that's the next thing to call. And that's going to be the primitive we use to build a linked list of components calling one another. And then it will export a greet function. And so what that implementation of that greet function in each of these languages will be, call next. And if it is empty string, because we don't yet have optional imports to say that, we've terminated this linked list, return it. Otherwise, format it with the language I'm implementing this in. So let's take a look at what this looks like for C. We're calling that next function. We're saying, it gave me an empty string, so I'm just going to say C. Otherwise, I format a string C and whatever the next one was. Okay. So this is effectively implemented in several different languages. So we have Golang, we have JavaScript, we have Python, and we have Rust. And so all the implementations are the same. Really, the only difference here is what the language was for that particular component. And then finally, we're going to invoke all this from, there is another terminal component, and that's serving as a workaround for not having optional imports. So that is going to be the thing that returns an empty string to know that we're done with this linked list. And then finally, we have just a CLI component that imports a greet function and calls it and prints it out. If you gave it the terminal, we'll just say hello. Otherwise, it says hello from all the languages we linked in. If you happen to see Robin's presentation from WASMCon about having the sort of the tower of languages using the registry and WASM Compose, this is sort of analogous to that, just with web. So finally, we get to some WAC. Sorry for the lack of syntax highlighting. I'm working also in my spare time on a language service for WAC and by extension WIT that would colorize this as well as potentially give us code completions, go to definitions, hovering over types and things. But that's a long way off. So we start with a package declaration like we do in WIT, except with this, we have this extension called targets, and this is totally optional. But what this is saying is, I know that my composition is going to give you a CLI command component. Please statically verify that I didn't get this wrong throughout my composition, an error if you do. And I'll show you what that looks like in a second. But we know that this thing will target a CLI command world, so it should conform to that world all is said and done. So we instantiate the terminal component and we give this ... syntax saying, if terminal imports WASI, I'll import WASI and just give it here. For Golang, we're going to say new Golang terminal greet should be the next for Golang and import the rest of it from the outside world. And we repeat this process on down for C, for Python, for JavaScript, for Rust, and finally the CLI. What we have down here is just simply saying whatever CLI exports, since I know this also exports a CLI command targeted world, we're going to actually conform to that world because all it's expecting is an export of the run interface. So that will give us the compliance of that targets static verification. So let's run this. So I have a tool called WAC. One of the subcommands you can give it is encode, and that effectively takes a WAC file and gives you the corresponding WAT or WASM representing that composition. By default, it will try to import all the components, so it doesn't create some monolithic component that copies everything into one place. But WASMTime can't run those yet, or possibly ever. So what this is doing is saying --define. Don't import them, define them inline. And so we should get a monolithic component as a result of this that doesn't have imports for other components. So we run this, and I'll try to make this larger so people can see. But since this is a registry aware version of WAC encode, it automatically downloaded all of the packages, including this WASI CLI package, which I pushed to this registry myself using WIT publish. But this is a warg-based registry, so that works today for warg, and OCI will hopefully work very soon. So this enables the developer experience to be, I author a file, I reference everything by package ID, and things work assuming a registry exists, which is opposite of what we have with WASM Compose today, where you have to copy everything locally, give it all paths to things, and it's not a very fun experience. So, okay, we have a very large CLI.wasm now, 46 megabytes, and that's because we have multiple different language runtimes being linked in to this one thing. So we have JavaScript to Python, and Golang, etc. So I'm just going to do a WASMTime CLI.wasm, and we should see that we get effectively the order of these operations, order of these languages, which was based off of the WAC definition of how we linked these things together. And if we change the WAC, generated the component again, we should get a different output. So I can very quickly do that. So let me get rid of this. And what I'm going to do is, rather than Rust greet here, I'm going to do a new demo Rust. And I'm going to say next is Rust greet. And I'm going to close that. Oh, let me do this. And that should be the greet export. So if I do that correctly, do that. And if I do WAC again, notice it didn't download anything again because it already cached everything. I purposely deleted the cache to show you it was downloading things in the first place. But now we have a new CLI. So if I run that, we should get 2 Rusts, and then we do 2 Rusts. Now what happens if we forget to conform to the world? Well, I'm just going to comment out the export, and let's go back to the command line. And if I encode this, we should get an error message. And I basically said, we failed to resolve this document. The target world requires an export named WASD-CLI run, but you didn't give me one. So that is some of the nice little static verification we could do to verify that the composition you got in the target world that you expect for this composition match. And then, it has pretty in-depth type verification for things that you pass around. So you get the types wrong of instantiation arguments. It gives you meaningful error messages pointing at the problem and what types mismatch and things like that. So that is WAC and a little demonstration of it. Not the most useful demonstration. I think we're all rushing out to go try to do, but this shows off some of the potential of having a text format that makes sense to people, that defines these effectively what turns into a DAG in a way that integrates with a registry to pull things from. So I just want to say that the repo is currently under my personal repo, but the intention is to move this tool to a BA repository in the near term. More than likely, it won't go into WASM tools because we will be taking a dependency on WASM time for the transform stuff, and that's a pretty heavy dependency to add to WASM tools. So it might be its own thing for composing, and we may try and integrate this the best we can into existing WASM tools compose, but we haven't quite decided how to land that for people just yet. I want to call out to say, please help us evolve the WAC language. If you're looking at the syntax and saying this is terribly confusing, that's great. I want to hear your feedback of ideas in which we can make this more intuitive for not just people. The problem is we're all very well versed with the WebAssembly component model ecosystem. I would love for people that aren't to look at this and say, what the hell is this? I was expecting it to work this way, because that I think would be the real valuable thing to get people that aren't working at the lowest level in the component model designing this language. So some known limitations of the tool: it can't break dependency cycles. So if you have a component that depends on A and B depends on A, we can't sort of inject a indirect component that automatically breaks that cycle and fixes that up for you. So that isn't implemented and probably not on the radar in the short term. It cannot currently handle resources exported by instantiations it makes. So we can import resources and pass them on down to things, but once you instantiate a component and export an interface that create a new concrete resource type, WAC will give you a big thumbs up saying, here's your composition, but that fails validation saying those resource types aren't actually correct. And that's because Alex did a much better job of implementing that check within the validator than WAC does. But that is something that absolutely needs to be fixed. And likewise, WASM Compose, I believe, also still has this limitation around that. And then finally, there's no programmatic API for this. So it's kind of all text-based right now. You give us text, we give you back an AST, and then we can resolve that AST to a composition and code the composition. So we will be implementing a friendlier API, similar to what we have composition graph within WASM Compose, to be able to programmatically link these things in without having to use WAC ASTs as the thing that drives the composition. And that is all I have. I'm happy to take questions or otherwise feedback or leaders and insults at this point. So. Thank you.
I just want to say that's an awesome demo, especially the part where you showed a real error message that said "will be wrong." That was absolutely my favorite part.
So looks like we don't have, oh, we did have questions. Sorry, I wasn't able to have this up while presenting, as most people can't. Yash said, no, Joel said, I'm super excited about the export statements since there's currently no way to do any of these things from WASM Compose. That is very true. WASM Compose has very limited support for what it can import and export. It's basically driven by what it discovers from the components you're linking together. And so there's no real explicit control over this. So this is a little bit further fine-grained from what you can get with WASM Compose and these things. Yash said, transforms sound exactly what WASM API tools should want to target. Yeah, I mean, this is born out of being in that breakaway. I just realized when we're describing the ability to transform a WIT interface into a remotely distributed component over some sort of RPC, that is a transform. We're basing off of a WIT file coming in and spitting out a component, but you could also just take the component and spit out, look at its exports and spit out a proxy for those exports to marshal something over RPC. So I think that will tie into this paradigm of transformers really well and be really powerful when they do. And Scott says, WASI decom. I literally said that to Luke as we were discussing that breakaway. I said, this is decom. Yeah. Any other questions? Yeah.
So the transform, does it actually do a transform with a component, or is it just like, I'm gonna generate a thing that's going to link with the component and link it for you?
Well, that's up to the transformer. So from WAC's perspective, we give you the bytes, you give us back bytes, and I will substitute any place that you reference that name for those bytes. So in the case of like doing something that might want to get linked in with the original, you would give me back something that was linked in with the original from the transformer.
Okay, but it could just give you something else.
Yes.
Like, here's a totally.
It needs to be a component.
It needs to be a component, but it could be like, I made this component from scratch.
Right.
Or some, okay.
Yep. Any other questions? Joel also said, Alex and I recently debugged and fixed some resource-related bugs in WASM Compose, which will open a PR for soon. That would mightily help WAC. Thank you, Joel. I will make sure that whatever fixes that go into WASM Compose also make it their way to WAC as well. I think that's all I have time for.
Let's give Peter another round of applause. All right. So with that, we are finished with our regular scheduled programming. We're basically on time. There are a number of different topics that other folks wanted to talk about while we're here, but I don't see these as required topics per se. But one of the things that came up earlier today was about maybe coming up with a plan before WASM.io and some of the things that we might want to work on. So I know some of us are going to stay in the room and try to figure that out. But for everybody else, you know, freedom is allowed if you would like. We're in a great city. If you're online, there's great online games you could be playing too, or, you know, your work. Up to you. But, you know, I really appreciate all the engagement, and I think that it was everybody here that made this summit awesome. And hopefully we can tear it up in the town tonight and have a good time, because we shipped Messi Preview 2 last week, and that's still really cool to me. Anything you want to say, Liam?
Thank you everybody for coming. This event is so amazing because of everybody that attended. And it was a huge effort on your parts to come and put up all the incredible content. There will be a couple of asks to maybe help try to socialize the content as quickly as we can. I think that was maybe a key lesson or opportunity that we had last year. So I love that we live streamed most of it because it's already public. You know, so let's get the blog post this summer to summarize some of it, and let's get a draft roadmap up there because I know that I mean people are messaging me. People looking for it, and if they're messaging me, I'm sure they're messaging you too. So let's do it. And I could use maybe a volunteer or two to help pack up, and another volunteer to maybe run drinks to the bar or from the bar. Would be great.
Yes.
While we stand around and hang out.
Great. Online folks, anything that you would like to add before I end the stream? All right.
Huge shout out to everybody who helped organize this. Liam and David, amazing work on supporting this, on facilitating it, and Bailey, this is stunning. Really, really amazing job organizing it and then running it flawlessly as far as I'm concerned.
Oh, thank you, Till. Well, before I start blushing on camera, I am gonna turn it off now. So thank you, everybody. And I'll see you online.